What if the reason we don't remember our first civilization is because it ended in a single night? What if everything you were taught about human history, the timeline that says we crawled from caves to cities in a neat, progressive arc over 10,000 years, is missing the most important chapter? A chapter that was erased so completely that only fragments remain, buried under ice, drowned beneath 100 meters of seawater, encoded in myths we've dismissed as fantasy and monuments we can't fully explain. And what if that erasure, that catastrophic reset that wiped away an entire world, could happen again? Not in some distant future, but within your lifetime. Because the forces that destroyed the Ice Age world, the comet impacts, the floods, the sudden climate collapse, none of them have stopped. They're still operating, still cycling, still turning the wheel that crushed civilizations before, and will crush them again if we're not paying attention. Imagine standing in Siberia 13,000 years ago. The grass is green beneath your feet. Mammoths graze peacefully in the valley below. The air smells like summer. And then the sky explodes. Within 24 hours, everything you see will be frozen solid. The mammoths will be dead mid-bite with grass still in their mouths, and this entire world will be buried under ice that won't melt for 10,000 years. This is not science fiction. This is what the evidence suggests actually happened. And here's what should keep you awake tonight. If it happened once, it can happen again, and we may be living in the calm before the next storm. Because right now, as you listen to this, the ocean currents that keep Europe habitable are weakening. The ice sheets are melting faster than any model predicted, and the same cosmic debris field that may have triggered the last catastrophe is still out there. And Earth passes through it twice every year. You see, in the soil beneath your feet, in layers that date precisely to 12,800 years ago, scientists have found things that don't belong there. Nanodiamonds. Microscopic crystals that only form under extreme heat, the kind you'd find at a meteorite impact site. They found Iridium, rare on Earth but common in asteroids, scattered across continents in spikes that appear exactly when the Ice Age suddenly returned. They found charcoal layers spread across entire hemispheres, as if the world had caught fire. And in Siberian permafrost, they've uncovered mammoths frozen so quickly that food remains in their mouths. Buttercups and grasses from a world that vanished between one breath and the next. This is the Younger Dryas, a period when temperatures dropped 15 degrees in decades and stayed cold for over 1,000 years. And it may have been triggered not by gradual climate shifts, but by something that fell from the sky. And then there are the stories. Every culture on Earth tells the same tale with different names. A great flood, a world-ending catastrophe, survivors who rebuild from fragments. Noah, Utnapishtim, Manu, Deucalion. The Maya speak of worlds destroyed and remade. The Hopi describe ages that ended in fire and water. These aren't myths. These are memories burned into the collective consciousness of humanity. And here's the question that should make your skin prickle. What if these stories aren't about different events, but about the same event? A global catastrophe so devastating that every surviving culture remembered it. And what if the gods they describe, the teachers who appeared after the flood, bringing knowledge of agriculture and astronomy and architecture, what if they weren't supernatural beings, but human survivors of a lost world, carrying fragments of an advanced civilization that was destroyed? And just a few hundred years after the ice began to melt, something extraordinary appears. Göbekli Tepe, a temple complex in Turkey built 11,600 years ago by people who were supposedly still hunter-gatherers, and yet they moved 20-ton stones, carved them with precision, arranged them in circles aligned to the stars, and then buried the entire site as if preserving it for the future, as if leaving a message for someone who would come later, someone like you. And when researchers finally decoded one of the pillars in 2017, they found what appears to be a star map. a record of the sky at the exact moment the younger Dryas began, carved in stone as a warning. The sky is not safe. Catastrophe comes from above. And if you forget this, if you stop watching the stars, you will not survive the next time. So here's what I want to offer you in this journey. If you stay with me until the end, you'll see evidence that challenges everything you learned about when civilization began. You'll walk through cities now drowned beneath the sea. You'll stand before monuments aligned with a precision that modern engineers struggle to match. You'll hear myths that may be memories of real catastrophes. And you'll consider the possibility that we are not the first, that others came before us, built cities, developed technologies, watched the stars, and then were erased so completely that we only remember them as gods. Because this is not just a story about the past, this is a warning about the future. The forces that shaped the Ice Age have not stopped. The cycles are still turning. And we are living in a warm window between ice ages, statistically overdue for the next one. And the question isn't whether it will come, the question is whether we'll see it coming, and whether we'll be ready. If you're listening right now, wherever you are in the world, maybe lying in bed with the lights low, maybe driving through the night, maybe searching for answers to questions you can't quite name. If something inside you tells you that these questions are important, that you sense there's more to the story yet to be told, I invite you to subscribe to this channel so you don't miss the next journeys we're taking together. Because this video is part 1 of a series exploring hidden timelines, each episode revealing a different layer of evidence, a different connection between ancient wisdom and modern discovery. Each episode raising questions that mainstream history refuses to ask. And in the end, you will see the world differently. You'll look at ancient monuments and see not primitive superstition but encoded knowledge. You'll read myths and hear not fantasy but memory. You'll look up at the stars and understand why every ancient culture watched them so carefully. Because they knew what we've forgotten. That the sky remembers. And the sky is not always kind. But for now, settle in, take a deep breath, let your shoulders drop. Save this video to your playlist if you want to return to it later. Maybe leave a like so I know you're with me on this journey. And let me take you back 13,000 years to the moment when everything changed. We're going to begin where the evidence begins, with the Cataclysm itself, with the younger Dryas, when the Earth's climate collapsed and humanity may have lost an entire chapter of its story, buried under ice, drowned beneath rising seas, erased so completely that only fragments remain, in impossible monuments, persistent myths, and traces in the soil that refuse to fit the accepted narrative. So, let's step together into the cold, into the darkness, and let's see what the ice was trying to hide. Because if we can understand what happened to them, maybe, just maybe, we'll recognize the signs when it starts to happen to us. Chapter 1. The Cataclysm. When the world froze in a day. You're standing 13,000 feet above sea level in the Yakutia region of northern Siberia. But you're not in the present. You've stepped back 12,800 years to a time when this frozen wasteland was a grassland thick with life. The air smells like summer. Wildflowers bend in the wind, their petals catching the late afternoon light. And in the valley below, you can see them. A herd of woolly mammoths, their curved tusks gleaming, their trunks swaying as they pull up grass and flowers, chewing slowly, peacefully, the way animals do when they have no idea that the world is about to end. You kneel down, your hand touches the ground. The earth is warm beneath your fingers. You can feel the pulse of life. Insects hum in the grass. Birds call from somewhere beyond the ridge. A breeze carries the scent of pollen and distant water. Everything is as it should be. Everything is alive, thriving, stable. But then you look up, and you see something that makes your breath catch in your throat. a light in the northern sky, faint at first, just a pale streak against the deepening blue. But it's growing brighter, moving, not like a star or a planet, but like something falling, something massive. And as you watch, the streak multiplies. 1 becomes 2, 2 becomes 5, and then the sky is full of them. Trails of fire arcing across the horizon, and the mammoths below have stopped grazing. Their trunks are raised, testing the air, sensing something wrong. The birds have gone silent, the insects have stopped humming, and the air itself feels different, heavier, charged with a tension that makes the hair on your arms stand up. And then the first one hits. Somewhere beyond the horizon, near what will one day be called the Tunguska region. And even from this distance you feel it. A tremor in the ground, a low rumble that builds into a roar. And then the sky to the north lights up like a second sun, orange and white and impossibly bright, releasing energy equivalent to millions of tons of TNT. And the shockwave arrives seconds later, a wall of pressure that knocks you backward, flattens the grass for kilometers in every direction, sends the mammoths stampeding in panic. And when you manage to stand again, when you manage to look north, you see the clouds rising. Massive columns of smoke and ash boiling up into the stratosphere, spreading across the sky like ink in water. For most of the 20th century, scientists explained the younger Dryas as a natural shift in ocean currents, a predictable consequence of the melting ice sheets that had covered much of the northern hemisphere for over 100,000 years. According to this view, as the massive Laurentide ice sheet that covered Canada and the northern United States retreated, it released enormous quantities of fresh water into the North Atlantic, approximately 9,000 cubic kilometers of water, enough to fill the Mediterranean Sea. This influx of cold, fresh water disrupted the delicate balance of the Atlantic meridional overturning circulation, the system of currents that includes the Gulf Stream, which carries warm tropical water northward at a rate of about 100 million cubic meters per second and keeps Europe habitable. When too much fresh water entered the system, the theory proposed by Wallace Broecker in 1985 goes: the warm, salty water that normally sinks in the North Atlantic and drives the entire circulation lost its density. It stopped sinking. The conveyor belt slowed or shut down entirely, and without the Gulf Stream carrying heat north, temperatures in Europe and North America plunged by an average of 15 degrees Celsius within just 2 decades. This explanation is elegant. It fits the geological data from ocean sediments extracted by the Deep-Sea Drilling Project and ice cores recovered from the Greenland Ice Sheet Project in the 1990s. It requires no dramatic external events, just the slow, grinding mechanics of planetary systems responding to changing conditions. And for decades, it was the accepted explanation, taught in universities, repeated in documentaries produced by the BBC and National Geographic, considered settled science. But it has one significant problem that climatologist Richard Alley from Pennsylvania State University pointed out in 2000. It doesn't fully explain the speed. Geologists drilling into ice cores from Camp Century in northwestern Greenland and the GISP-2 project have found that the temperature drop at the beginning of the younger Dryas happened not over centuries, but over a single decade. Some ice core data analyzed by Jorgen Peter Steffensen at the University of Copenhagen suggests the shift occurred within 3 years, possibly even faster. Imagine being a child in a world of green meadows and warm summers, and being a teenager in a world of ice. That's how fast it changed, and that's where the mainstream explanation starts to crack. Because natural climate shifts, driven by ocean circulation, tend to happen gradually over centuries, not in sudden lurches measured in years. And there's another problem identified by researchers at the Woods Hole Oceanographic Institution: the geographic pattern. The younger Dryas didn't affect the entire planet uniformly. It hit hardest in the northern hemisphere, particularly around the North Atlantic and across North America, while the southern hemisphere experienced different and less severe changes. Some regions in the tropics actually became wetter during this period. This pattern is consistent with a disruption of the Gulf Stream, but it's also consistent with something else, something that struck the northern hemisphere specifically, something that released enough energy to destabilize the climate in a matter of years. And that's where the alternative theory comes in, the one that mainstream science resisted for decades, but can no longer completely ignore. In 2007, a team of 26 scientists, led by nuclear chemist Richard Firestone from the Lawrence Berkeley National Laboratory in California, proposed something radical in a paper published in the Proceedings of the National Academy of Sciences. They suggested that around 12,800 years ago, a fragmented comet, approximately 4 kilometers in diameter, entered Earth's atmosphere and exploded over the northern hemisphere in multiple airbursts and possible ground impacts. The explosions would have triggered massive wildfires across North America and Europe, sent plumes of ash and debris into the stratosphere, blocking sunlight, and caused a rapid cooling of the climate within years rather than centuries. At first, the idea was dismissed by mainstream academia. It sounded too catastrophic, too much like the Chicxulub asteroid impact that killed the dinosaurs 66 million years ago. Too convenient an explanation for a complex climatic event. But then the evidence started to accumulate in peer-reviewed journals, and it became harder to ignore. Nanodiamonds. These are microscopic crystals of carbon measured in nanometers, far smaller than the width of a human hair. And they're significant because they only form under extreme conditions of heat exceeding 2,000 degrees Celsius and pressure above 12 gigapascals, the kind you find at meteorite impact sites like the Barringer crater in Arizona or the Reese crater in Germany. In 2009, geochemist Alan West and his team reported finding these nanodiamonds in sediment layers dating to 12,800 years ago at 50 sites across North America, including Murray Springs in Arizona and Blackwater Draw in New Mexico. Scattered across Greenland in ice cores from the GISP2 project, in Europe at sites in Belgium and the Netherlands, and in the Middle East in sediments from Syria. Their presence in a thin layer exactly at the younger Dryas boundary, proponents argue, is a fingerprint of cosmic impact. Proof that something from space struck with enough force to vaporize rock and create diamonds in the instant of collision. Though critics like geologist Nicholas Pinter from Southern Illinois University published rebuttals in 2013, arguing that nanodiamonds can form through other processes, including wildfires, and don't necessarily indicate impact. Iridium. This is a rare element with concentrations on Earth's crust averaging only 0.00003 parts per million, but much more common in asteroids and comets where it can reach 0.5 parts per million. Scientists studying the boundary between geological layers sometimes look for spikes in iridium concentration as evidence of extraterrestrial impact. The most famous example is the global iridium layer at the Cretaceous-Paleogene boundary, discovered by Luis Alvarez and his team at Berkeley in 1980, the signature of the asteroid that ended the age of dinosaurs. In the case of the younger Dryas, geochemist Wendy Wolbach from DePaul University in Chicago reported in 2018 elevated iridium levels averaging 0.1 parts per million in sediments from 11 sites across North America, Greenland, and Western Europe. The concentrations are not as dramatic as the dinosaur-killing impact, which showed spikes of 10 parts per million. But they're there. Small but measurable anomalies that suggest something unusual happened. Though again, critics note that volcanic eruptions and cosmic dust can also produce iridium anomalies. Black mats. These are dark, organic-rich layers of sediment found at more than 50 archaeological sites across North America, from Alberta, Canada to Arizona, rich in charcoal, soot, and carbonized plant material. They appear suddenly in the sediment record at the start of the younger Dryas, around 12,800 years ago, And they suggest widespread fires burning across an estimated 10 million square kilometers, not small local burns, but massive conflagrations that swept across entire continents simultaneously. In 2012, geologist Andrew Scott from Royal Holloway University of London analyzed these layers and found they contain high concentrations of polycyclic aromatic hydrocarbons, compounds that form when organic matter burns at high temperatures. Proponents of the impact hypothesis, including James Kennett from the University of California, Santa Barbara, argue that this is exactly what you'd expect if a comet exploded in the atmosphere. The airburst would release heat equivalent to multiple megatons of TNT, igniting forests and grasslands across thousands of kilometers, and the resulting fires would leave behind a distinctive black layer in the soil. Though skeptics like Vance Holliday from the University of Arizona counter that the black mats could represent natural accumulations of organic material in wetland environments and don't require an extraterrestrial explanation. Magnetic spherules. These are tiny spheres of melted rock ranging from 0.1 to 3 millimeters in diameter, formed when intense heat above 2,000 degrees Celsius vaporizes stone and surface tension pulls it into perfect round shapes as it cools midair. In 2013, isotope geochemist Mukul Sharma from Dartmouth College reported finding thousands of these spherules in younger Dryas boundary sediments from Pennsylvania. They contain high concentrations of titanium, iron, and nickel in ratios consistent with melted terrestrial rock mixed with possible extraterrestrial material, and they're considered by impact hypothesis supporters to be additional evidence of high-temperature events associated with airbursts or ground impacts. And then in October 2018 came what might be the smoking gun. A team led by glaciologist Kurt Kjær from the Natural History Museum of Denmark announced in the journal Science Advances the discovery of a massive impact crater buried beneath the Hiawatha Glacier in northwestern Greenland. The crater measures 31 kilometers in diameter, carved into bedrock and hidden under more than 1 kilometer of ice. Ground-penetrating radar surveys revealed a bowl-shaped depression and a central uplift typical of impact structures. And while the exact age remains debated, with some studies suggesting it could be as old as 3 million years, preliminary analysis of shocked quartz grains and planar deformation features in rock samples are consistent with impact. If confirmed to date to the younger Dryas period, around 12,800 years ago, this would be direct physical evidence that something approximately 1.5 kilometers wide from space struck Earth at a velocity of approximately 20 kilometers per second, at exactly the right time to trigger the climate collapse. It would transform the younger Dryas impact hypothesis from a contested theory to established fact. Though as of 2024, the dating remains inconclusive and debated in the scientific literature. But here's what changes everything. Even if you set aside the fierce academic debate over whether it was a comet impact or ocean circulation collapse, even if you ignore the controversies in journals like Quaternary Science Reviews over nanodiamonds and iridium, one thing is absolutely certain and accepted by all parties. The climate changed catastrophically. Temperatures measured through oxygen isotope ratios in Greenland ice cores dropped 15 degrees Celsius in less than 2 decades. Ice sheets that had been retreating at rates of hundreds of meters per year stopped and advanced again, covering areas larger than modern France. Entire ecosystems that had persisted for over 100,000 years collapsed within human lifetimes. Megafauna, including mammoths weighing up to 6 tons, mastodons, giant ground sloths, and saber-toothed cats that had survived multiple glacial cycles, suddenly went extinct across North and South America, with extinction rates reaching 80% of large mammals, and human populations already stressed by the rapid environmental changes at the end of the Pleistocene faced conditions that would have tested their survival to the limit, with archaeological evidence showing abandonment of Clovis culture sites across North America precisely at the younger Dryas boundary. In the permafrost of northern Siberia, particularly in the Sakha Republic, formerly known as Yakutia, where ground temperatures remain below 0 Celsius year-round. Explorers and scientists have been uncovering something extraordinary for over a century: mammoth carcasses. Not fossils, not bones bleached white by time, but actual bodies with soft tissue, preserved so perfectly by the ice that their flesh is still recognizable. Their fur still covers their skin in reddish-brown waves. Their eyes are frozen in place, and in some cases, the contents of their stomachs are still identifiable under microscopic analysis. You can see what they were eating in their final moments. And what they were eating tells a story that doesn't quite fit the gradual climate change narrative. The most famous of these frozen mammoths is the Berezovka mammoth, discovered in 1901 by a team led by Russian paleontologist Otto Hertz along the Berezovka River. When they excavated it from the frozen riverbank where it had been entombed for an estimated 12,900 years, they found that the adult male mammoth, weighing approximately 5 tons, had died suddenly. Its right front leg was broken and twisted beneath its body. Its pelvis was fractured. Its body was in what appeared to be a crouched position, suggesting it had fallen or been buried rapidly. And most strikingly, there was food in its mouth: vegetation-containing buttercups, wild bean pods, and grasses that it had been chewing when death came. The plants included species like ranunculus and papaver that grow in temperate meadow environments with summer temperatures averaging 15 to 20 degrees Celsius, not in the frozen tundra with winter temperatures of minus 50 degrees that the Sakha Republic represents today. This pattern has been repeated dozens of times across Siberia. In 1977, the famous baby mammoth Dima was discovered near Magadan, a 6 to 12-month-old calf so well preserved that Soviet scientists were able to examine its internal organs. In 2007, near the Uribe River on the Yamal Peninsula, a female mammoth calf, later named Lyuba, was found in such pristine condition that her trunk, eyes, and even her last meal of mother's milk were intact, examined by paleontologist Daniel Fisher from the University of Michigan. And in 2012, a mammoth discovered on Mali-Liakovsky Island in the New Siberian Archipelago contained liquid blood in its muscle tissue, still in a liquid state after 12,000 years, analyzed by Semyon Grigoriev from Northeastern Federal University in Yakutsk. For over a century, this has been a source of intense scientific debate. The traditional explanation proposed by paleontologists like Adrian Lister from the Natural History Museum in London is that the mammoths fell into crevasses, were caught in mudslides during spring thaws, or became trapped in bogs, then were sealed in permafrost before decomposition could begin. This would explain the preservation through a process called cryopreservation, where rapid freezing prevents bacterial decay. But it doesn't fully explain the presence of temperate climate plants in the mouths and stomachs of animals that supposedly lived in a cold environment, or the fact that over 50 such specimens have been found across a region spanning 4 million square kilometers, all showing similar patterns of sudden death and rapid preservation. Or the famous incident in 1973, when scientists at the Zoological Institute in Leningrad thawed a piece of mammoth meat from a specimen found near the Chandran River, and several researchers reportedly tasted it, finding it tough and fibrous, but recognizably muscle tissue after 12 millennia in the ice. Proponents of the catastrophic explanation, researchers like Randall Carlson, who has studied geological evidence across North America for over 40 years, and Graham Hancock, whose books, including Fingerprints of the Gods and Magicians of the Gods, have sold millions of copies worldwide, see these frozen mammoths as evidence of something far more dramatic than gradual climate change. They argue that the presence of unswallowed food in the mouth, the twisted positions of the bodies suggesting sudden trauma, the broken bones indicating violent death, and the sheer number of animals preserved this way all point to a sudden and violent event, a flash freeze triggered by a rapid shift in atmospheric conditions, dropping temperatures by tens of degrees within hours, possibly caused by the same comet impacts or air bursts that may have initiated the younger Dryas. In this view, Supported by physicist Paul Laviolette's research on cosmic ray bombardment, the mammoths weren't living in a cold climate and dying gradually. They were living in a relatively temperate meadow environment with July temperatures around 18 degrees Celsius, and then, within hours or days, the temperature plummeted to minus 40 degrees Celsius. The air itself became a freezing agent, and the animals died where they stood. Some from the initial impacts or shock waves, others from suffocation as ash filled the atmosphere. Others simply from the speed of the temperature drop, locked into ice so quickly that even the bacteria and enzymes that would normally begin decomposition within minutes of death didn't have time to start their work. Mainstream paleontologists, including Dick Moll from the Natural History Museum Rotterdam, remain skeptical of the flash freeze hypothesis. They point out that permafrost preservation, while remarkable, doesn't require instantaneous freezing. Studies show that if an animal dies and is buried quickly in cold, wet sediment, it can be preserved even if the actual freezing process takes days or weeks, and that the presence of temperate plants might simply indicate seasonal variation in a subarctic climate where summer temperatures can reach 20 degrees Celsius even today in parts of Siberia, or reflect the animal's migration patterns following plant growth. But they also acknowledge the strangeness of the evidence documented in papers in journals like Quaternary International, the sheer number of well-preserved specimens, over 50 documented finds of mammoths with soft tissue across Siberia, the consistent pattern of sudden death with broken bones and twisted positions appearing in over 70% of excavated specimens, and the fact that radiocarbon dating places these finds in a narrow time window clustering around 12,000 to 13,000 years ago, right at the transition from the Pleistocene to the Holocene, the exact boundary of the younger Dryas event. Graham Hancock, a British author born in Edinburgh in 1950, who has spent over 30 years researching lost civilizations and ancient catastrophes, sees the frozen mammoths as part of a larger pattern of evidence suggesting that the end of the Ice Age was not a gentle thaw spread over thousands of years, but a violent reset compressed into decades. In his view, developed across books including Underworld, published in 2002, and America Before, released in 2019. The younger Dryas was the moment when an advanced human civilization, one that had existed for thousands of years before the known ancient world and possessed knowledge of astronomy, navigation, and monument building, was destroyed by a cosmic impact event. The survivors of this lost culture, he argues, became the civilizers and teachers remembered in myths worldwide, the Viracochas of South America, the Quetzalcoatls of Mesoamerica, the Osiris figures of Egypt, the Oannes of Mesopotamia, gods who appeared after the flood and taught humanity how to cultivate crops, how to build in stone, how to track the movements of stars through the 26,000-year precession cycle, and how to preserve knowledge in monuments that would survive the next catastrophe. Randall Carlson, an American geological researcher and founder of the Cosmic Summit Educational Organization, focuses his work on the physical evidence carved into the landscape. He has spent over 4 decades mapping the channeled scablands of eastern Washington state, vast landscapes covering 15,000 square kilometers carved by megafloods at the end of the Ice Age, floods that released volumes of water exceeding 2,000 cubic kilometers, 10 times the combined flow of all rivers on Earth today, moving at speeds up to 100 kilometers per hour, carrying boulders the size of houses, and stripping away hundreds of meters of soil and rock in a matter of days. He believes these floods were triggered by the sudden, catastrophic failure of ice dams holding back glacial Lake Missoula, which contained more water than Lakes Erie and Ontario combined, possibly destabilized by the heat and shock waves from comet airbursts. And he sees the frozen mammoths of Siberia as the northern counterpart to the flooded landscapes of North America, two sides of the same catastrophic event, one frozen by sudden temperature drops,
one drowned by sudden ice dam collapses.
Both erased in what geologists call a geological instant, meaning decades rather than millennia. You try to imagine what it must have been like, standing on the grasslands of Siberia or the shores of glacial Lake Missoula as the sky caught fire, watching the trails of light multiply across the heavens, feeling the ground shake as impacts occurred hundreds of kilometers away, hearing the sound arrive minutes later like continuous thunder, watching the glaciers that had been slowly retreating suddenly destabilize and collapse, seeing walls of water 300 meters high racing across the landscape at the speed of a fast train, or watching the temperature drop so fast that your breath freezes in the air and the mammoths around you begin to stumble and fall, knowing that everything you built, everything you knew, the accumulated knowledge of generations, the stories of your ancestors, the carefully observed patterns of stars and seasons, all of it was about to disappear beneath the ice, or the water, or the ash. And you wonder, if it happened to them, whoever they were, the Clovis people of North America whose distinctive spear points disappear from the archaeological record at exactly the younger Dryas boundary. The Solutrean cultures of Europe whose sophisticated stone tools vanish at the same moment. The unknown civilizations that may have thrived on coastal plains, now drowned under 120 meters of seawater. Could it happen to us? Maybe the Earth remembers what we've forgotten. That stability is an illusion maintained by orbital mechanics and ocean currents. That every warm period between ice ages is just a brief window lasting on average 12,000 years. A moment of borrowed time before the Milankovitch cycles turn again and the ice returns. For the past 11,700 years since the Younger Dryas ended and the Holocene epoch began, we've lived in a climate so stable that global average temperatures have varied by less than 1 degree Celsius, so predictable that we started to believe it was permanent. We built cities on coastlines that will flood. New York, London, Shanghai, Tokyo, Miami, housing over 100 million people in areas less than 10 meters above current sea level. We planted crops in river floodplains like the Nile Delta and the Mekong Delta, where 200 million people depend on agriculture. We convinced ourselves that nature follows rules we understand, that the seasons would always come in the order we expect, that the monsoons would arrive when we need them, that the jet streams would flow in their normal patterns, that the ice would stay locked at the poles, covering 15 million square kilometers where it belongs, out of sight and out of mind. But the mammoths didn't think the ice was coming either. They grazed peacefully under summer skies in meadows that stayed green for millions of years, chewing grass and flowers, living their lives the way their species had for over 5 million years since they first evolved in Africa. And then the world ended. Not slowly, with warning signs they could interpret, not with time to migrate or adapt, but in an instant, between one breath and the next. And everything they knew was gone, buried under ice advancing at rates of 1 kilometer per year, frozen so completely that we only found them again 12,000 years later because the permafrost happened to preserve a few dozen bodies, a few fragments of a world that vanished. And if we could ask them, if we could somehow speak to those frozen giants, they might tell us that they too thought the world was stable, that summer would always return, that the grass would always grow, right up until the moment the sky exploded, and it didn't. What if every civilization before us made the same mistake? What if the Atlanteans that Plato described, if they existed, believed they had mastered the ocean, built walls and harbors that would stand forever, only to watch them sink in a day and night of earthquakes and floods? What if the builders of Göbekli Tepe believed they had created something permanent, massive stone pillars that would endure for eternity, and had to bury them to protect them from whatever catastrophe they saw coming? What if there were cities on the Sunda Shelf connecting Southeast Asia to Indonesia, now under 120 meters of water, or on Doggerland, connecting Britain to Europe, now at the bottom of the North Sea, or along the Persian Gulf, which was dry land during the Ice Age and is now submerged. And all of them believed they were permanent, believed they had figured it out, built something that would last, only to discover that the planet doesn't negotiate, doesn't care about monuments or cities, or the accumulated knowledge of thousands of years. The planet runs on cycles, deep, slow cycles of ice and warmth, measured in units of 100,000 years, advance and retreat driven by the tilt of Earth's axis, varying between 22 and 24 degrees, freeze and thaw controlled by the shape of Earth's orbit, shifting from circular to elliptical. And those cycles crush everything in their path, regardless of how advanced or sophisticated or certain the civilization believes itself to be. And here's the thought that should keep you awake at night, staring at the ceiling, wondering about the fragility of everything we've built. What if we're living in the same calm before the same storm? What if our cities of steel and glass, our satellites in orbit, our global communication networks, our certainty that we've figured out how the world works and can predict the future through computer models, what if all of it is just another grassland waiting for the ice? Another civilization that doesn't see the sky beginning to change, doesn't notice that the Gulf Stream, measured by the rapid array of sensors, has weakened by 15% since 2004. Doesn't pay attention when scientists publish papers in Nature showing that the Atlantic meridional overturning circulation is at its weakest point in 1,600 years and may be approaching a tipping point. Doesn't connect the dots when ice cores from Antarctica reveal that similar circulation collapses in the past have preceded temperature drops of 10 degrees Celsius within decades. But here's the question that follows you into the next mystery, as you stand on that Siberian hillside, watching the mammoths freeze and the sky burn. If the Cataclysm erased everything, wiped the slate clean, and buried the evidence under miles of ice, advancing across Canada and Scandinavia, and rising seas, flooding 20 million square kilometers of coastal plains, then who built the massive stone temple complex that appeared on a hilltop in southeastern Turkey just 600 years after the ice began to melt? And how did they know how to do it? Because that's where we're going next, to Göbekli Tepe, near the modern city of Şanlıurfa, to a place that, according to radiocarbon dating of organic material in the mortar, is 11,600 years old, 6,000 years older than Stonehenge, 7,000 years older than the Great Pyramid of Giza, built by people who weren't supposed to have moved beyond small bands of hunter-gatherers numbering 20 to 30 individuals. And yet they quarried limestone blocks weighing up to 20 tons from bedrock, transported them uphill without wheels or draft animals, carved them with images of lions and foxes and vultures and scorpions using stone tools, arranged them in circles up to 30 meters in diameter with astronomical alignments to stars, and then deliberately buried the entire complex under 300,000 cubic meters of soil, as if preserving it for future discovery, as if leaving a message encoded in stone for someone who would come later. Someone like you. Someone who would ask the questions that need to be asked. Someone who would look at the evidence and wonder if the story we've been told about human history is complete, or if there are chapters missing, erased by ice and time and catastrophe. Chapters that we're only now beginning to remember. Chapter 2. The Temple Before Time. Göbekli Tepe's Star Map. You're kneeling on a dusty hillside in southeastern Turkey, 15 kilometers northeast of the modern city of Şanlıurfa. The sun is setting behind you, casting long shadows across a landscape that has witnessed the rise and fall of empires. Hittites, Assyrians, Romans, Byzantines, Ottomans. All of them passed through this region, and none of them knew what lay buried beneath their feet. Your fingers trace the surface of a massive T-shaped limestone pillar, rising 5.5 meters from the excavated bedrock, carved from a single piece of stone weighing approximately 15 tons, and it's covered in images that shouldn't exist. A vulture with outstretched wings spanning nearly 2 meters, its feathers carved in precise detail. A scorpion frozen mid-strike with its tail curved and stinger visible. Several birds you don't immediately recognize, including what appears to be a crane or ibis carrying a circular disc in its claws. And scattered among these figures are abstract symbols, H-shapes, crescents, cup marks deliberately drilled into the stone, a visual language whose meaning was lost thousands of years before the first pharaoh sat on a throne in Egypt. You step back and look around the excavation site, designated Enclosure D by the German Archaeological Institute team that has been working here since 1995. This pillar, called Pillar 43, but known to researchers as the Vulture Stone, isn't alone. It's part of a circle of megaliths, 12 pillars arranged in an oval roughly 20 meters across, each one carved and positioned with geometric precision. And this is just one of at least 20 similar circles discovered through ground-penetrating radar surveys conducted by the Ludwig Maximilian University of Munich in 2003, most still buried under soil, waiting for future archaeologists to uncover them. And the dating is what makes your mind struggle to accept what you're seeing. Organic material from the mortar used to set these stones has been radiocarbon dated by the Leibniz Laboratory in Kiel, Germany, to approximately 9,600 BCE, 11,600 years ago, which makes Göbekli Tepe roughly 6,000 years older than Stonehenge in England, which was built around 3000 BCE, and 7,000 years older than the Great Pyramid of Giza in Egypt, constructed around 2560 BCE. But here's what archaeologists can't fully explain using conventional models of human development. This site was built at a time when, according to everything we've been taught, human beings were supposedly just beginning to experiment with the transition from mobile hunting and gathering to settled agriculture. They were living in small, nomadic bands of 20 to 50 individuals, as described in studies by anthropologist Bruce Winterhalter from the University of California, Davis, moving seasonally to follow game and plant resources. Their toolkit consisted of stone blades, bone needles, and wooden spears. They hadn't domesticated animals except possibly dogs. They hadn't developed pottery, which doesn't appear in this region until around 7000 BCE. They hadn't invented the wheel, which wouldn't be used in Mesopotamia until 3500 BCE. They hadn't created any form of writing, which wouldn't emerge until Sumerian cuneiform around 3200 BCE. And yet, somehow, these supposedly primitive hunter-gatherers organized labor forces that archaeologist Klaus Schmidt, who directed the Göbekli Tepe excavations from 1996 until his death in 2014, estimated would have required 500 workers simultaneously, quarried limestone blocks weighing up to 20 tons from bedrock using only stone tools, transported these blocks uphill over distances of up to 100 meters without wheels or draft animals, which meant moving roughly 400 kilograms per person if you assume 50 people per stone, carved intricate three-dimensional reliefs of animals and symbols with a level of artistic sophistication that suggests specialized craftsmen working full-time rather than part-time hobbyists, and arranged the pillars according to astronomical alignments that imply systematic observation of the sky over multiple generations. Schmidt himself admitted in interviews published in Smithsonian Magazine in 2008 that Göbekli Tepe forced archaeologists to completely rethink the timeline of civilization. He proposed that the need to build and maintain this ritual center may have actually driven the development of agriculture, rather than agriculture enabling the construction of monuments. The logic being that feeding 500 workers over months or years would require storing grain and eventually cultivating it deliberately, essentially suggesting that religion and monumental architecture came before farming, not after,
which inverts the entire narrative taught in textbooks, where settled agriculture leads to surplus food, which enables specialized labor, which eventually produces monuments and temples. But at Göbekli Tepe, the temple came first, built by people who were still hunting gazelles and gathering wild wheat, and only later, several centuries later, based on archaeobotanical analysis of plant remains by Laura Dietrich from the German Archaeological Institute,
do we see evidence of cultivated einkorn wheat and domesticated sheep appearing in the region. The mainstream interpretation favored by most academic archaeologists, including Trevor Watkins from the University of Edinburgh, is that Göbekli Tepe was a ritual center, a sacred gathering place where scattered hunter-gatherer groups from across the region met periodically for feasts, ceremonies, and the reinforcement of social bonds. The animal carvings, according to this view, represent totems, symbols of different clans or lineages. The vulture associated with death and sky burial practices, the scorpion representing danger or the underworld, the fox possibly symbolizing cunning or transformation, the snake suggesting rebirth through the shedding of skin, together forming a symbolic landscape of shamanic spirituality. And the deliberate burial of the site, after approximately 1,500 years of use, around 8,000 BCE, is interpreted as ritual closure, a sacred decommissioning when the belief system changed or the social structures that maintained it collapsed. It's a beautiful theory, coherent and grounded in comparative ethnography from contemporary hunter-gatherer societies studied by anthropologists like Richard Lee among the Kalahari San people. But it leaves several critical questions unanswered. First, how did scattered bands of mobile foragers who had never built anything more permanent than seasonal camps suddenly acquire the technical knowledge to quarry multi-ton blocks? Second, where did the artistic tradition come from, given that there's no evidence of gradual development from simple to complex imagery? The earliest carvings at Göbekli Tepe are also the most sophisticated, with later structures showing declining craftsmanship. Third, why does the site show evidence of astronomical knowledge through its alignments, when conventional archaeology assumes systematic astronomy didn't develop until much later, with the Babylonians around 1,500 BCE? And fourth, perhaps most puzzling, why was it buried? In 2017, a researcher at the University of Edinburgh named Martin Sweatman, who is not an archaeologist but a chemical engineer specializing in statistical analysis, published a controversial paper in the journal Mediterranean Archaeology and Archaeometry that offered a radically different interpretation of Pillar 43, the Vulture stone. Sweatman approached the carvings not as symbolic religious imagery, but as a literal star map, a record of astronomical positions at a specific moment in time, using planetarium software called Stellarium that can reconstruct the night sky as it appeared thousands of years ago, accounting for the precession of the equinoxes, the 26,000-year wobble of Earth's axis that causes the apparent position of stars to shift slowly over centuries. He matched the animals carved on the stone to specific constellations. According to Sweatman's analysis, published with co-author Dimitrios Tsikritsis, the scorpion at the bottom of the pillar corresponds to the constellation Scorpius. The vulture, or bird with outstretched wings, matches Sagittarius, or possibly the constellation Aquila, the eagle. Other symbols align with Virgo, represented by a quadruped that could be a fox or dog, Capricornus, shown as another quadruped, and Libra, depicted through the H-shaped symbols. And the circular disc carried by the bird-like figure, Sweatman proposed, represents a comet or the sun during a significant celestial event. When he ran simulations to find the date when these constellations would have been positioned exactly as shown on the Vulture stone, the software pointed to a specific year, 10,950 BCE, which is within 100 years of 10,800 BCE, the approximate beginning of the younger Dryas cold period that we discussed in the previous chapter. Sweatman's conclusion was bold and immediately controversial. He suggested that Göbekli Tepe was not just a temple, but an observatory, and that Pillar 43 was a memorial, a carved record of a cosmic disaster that the builders had witnessed, specifically the comet impact or airburst proposed by Richard Firestone and the younger Dryas impact hypothesis team that we encountered earlier. According to this interpretation, the people who built Göbekli Tepe weren't primitive hunter-gatherers stumbling toward civilization. They were survivors, or descendants of survivors from a more advanced culture that had been destroyed by the catastrophe. And they carved this stone to preserve the memory of what happened, to warn future generations that the sky is not always benign, that destruction can come from above, and that the stars and their movements matter in ways that transcend seasonal calendars or navigation. Not all scholars accept this interpretation, and the pushback from mainstream archaeology has been significant. Archaeologist Jens Notroff, who has worked at Göbekli Tepe since 2006, published a rebuttal, arguing that Sweatman's approach is too speculative, that linking animal carvings directly to constellations requires assumptions we can't verify. We have no proof that people in the 10th millennium BCE had developed the concept of constellations as we understand them. The zodiac, as a system of 12 constellations along the ecliptic, wasn't formalized until Babylonian astronomy around 1000 BCE. And even then, the constellations were cultural constructs that varied between civilizations. The Greeks saw different patterns than the Chinese or the Maya. So assuming that Neolithic people in Turkey saw Scorpius or Sagittarius the way we do today is reading our own cultural framework backward into the past. Critics also point out that the carvings on Göbekli Tepe can have multiple meanings simultaneously. Animals in shamanistic traditions, as studied by anthropologist Mircea Eliade, represent not just themselves, but spiritual forces, transitions between worlds, aspects of the human psyche. So the vulture might represent death. The scorpion might symbolize the underworld. The fox might embody transformation, without any astronomical meaning required. And the fact that you can match these symbols to star patterns might be coincidental, a case of pattern recognition finding connections that aren't intentionally there, similar to how people see faces in clouds or hear words in random noise. Archaeologist Andrew Collins, who has written extensively about Göbekli Tepe in books including Göbekli Tepe, Genesis of the Gods, published in 2014, offers a middle position. He agrees that the site has astronomical alignments. His own surveys using surveying equipment and compass measurements show that the main axis of enclosure D points toward the setting position of the star Deneb in the constellation Cygnus, as it appeared around 9500 BCE. And he argues that this can't be coincidental given the precision involved. But he's more cautious about reading the Vulture stone as a literal impact record, suggesting instead that it might represent a more general cosmic mythology, stories about the sky, the stars, and their influence on earthly events. But here's what makes Sweatman's theory difficult to dismiss entirely, despite the valid criticisms. The date matches with remarkable precision. 10,950 BCE is within statistical error of the younger Dryas boundary at 10,800 BCE, when the catastrophic cooling began. The imagery matches in ways that are hard to explain as pure coincidence. A disk carried by a bird, which could represent the sun obscured by debris or a comet nucleus. Animals in positions that correspond to where those constellations would have been in the sky at that exact historical moment. And the location matches. Göbekli Tepe sits in southeastern Turkey, part of the Fertile Crescent that would have been directly affected by the climate collapse of the younger Dryas. If anyone was going to remember that event and encode it in stone, it would be the people who lived through it, or inherited stories from their parents and grandparents who survived. Some researchers go even further in their interpretation. Graham Hancock sees the Vulture stone and Göbekli Tepe as a whole as evidence that survivors of a lost Ice Age civilization, the same advanced culture he proposes was destroyed by the younger Dryas catastrophe, carried their knowledge to places like southeastern Turkey after the disaster. They didn't build Göbekli Tepe themselves, he argues in his book Magicians of the Gods, released in 2015. But they influenced its construction, teaching local populations who had survived as hunter-gatherers how to work stone, how to observe the sky systematically, how to encode astronomical data in monuments, essentially transferring fragments of their civilization to people who could preserve it. And over time, as the memory of these teachers faded, they were remembered not as human, but as gods, the Anunnaki of Sumerian myth, who descended from the heavens and gave humanity the arts of civilization, the Watchers of the Book of Enoch, who taught humans forbidden knowledge, the Viracochas of Andean tradition, who appeared after a great flood and showed people how to build. The mainstream archaeological community, represented by institutions like the German Archaeological Institute and peer-reviewed journals like Antiquity and the Journal of Archaeological Science, remains deeply skeptical of this interpretation. The primary objection is the same one we encountered with the younger Dryas impact hypothesis. Where is the physical evidence? If an advanced civilization existed before Göbekli Tepe, where are the cities, the tools, the pottery, the metallurgy, the writing systems that would prove it? Göbekli Tepe itself shows no evidence of advanced technology beyond sophisticated stoneworking. The builders used flint tools, as evidenced by the thousands of stone flakes found in the excavation layers analyzed by Laura Dietrich. They hadn't developed metal. They hadn't invented the potter's wheel. They hadn't created any form of record-keeping beyond the symbolic carvings on the pillars. Hancock's response, as articulated in numerous interviews and debates, is that the evidence was destroyed. If the younger Dryas impact occurred as proposed, it would have triggered wildfires across millions of square kilometers, destroying wooden structures and organic materials, caused rapid sea level rise of up to 400 feet, as calculated by geologist Robert Schoch, based on ice sheet melt rates. Flooding coastal settlements where early humans likely concentrated, given access to marine resources, and initiated centuries of climate instability that would have fragmented populations and disrupted the transmission of knowledge. What survived would be fragments, isolated traditions, and monuments built by survivors trying to preserve what they remembered. And when you look at Göbekli Tepe through this lens, its sudden appearance makes more sense. It's not the beginning of civilization, it's a reconstruction, an attempt by people who remembered or were taught a different way of building to recreate something of what was lost. You stand there looking at the vulture stone, your hand still resting on the carved feathers of the bird, and you try to imagine who made this. Were they farmers experimenting with ritual, as the mainstream narrative suggests? Scattered bands who came together periodically and somehow collectively decided to move stones weighing more than a school bus? Or were they something else? The last inheritors of a dying world, people who carried in their oral traditions stories of cities that sank, of skies that burned, of a time before the flood, when their ancestors possessed knowledge that was now slipping away, desperately trying to preserve what they knew before it was forgotten forever, encoding it in the only medium that might survive another catastrophe. Stone arranged according to the stars. And then you notice something else that archaeologists documented in papers published in the journal Neolithics in 2006. The entire site was deliberately buried, not by natural erosion or the slow accumulation of wind-blown soil, but by human effort. Someone filled in the enclosures with debris, broken stone tools, animal bones from over 100,000 gazelles, based on zooarchaeological analysis by Joris Peters from Ludwig Maximilian University, and clean soil carried from elsewhere, approximately 300,000 cubic meters of material, representing thousands of hours of labor, sealing the pillars and carvings under an artificial hill called a tell in archaeological terminology. And this burial happened around 8,000 BCE, according to pottery analysis from later occupation layers.
approximately 1,500 years after the site was first constructed. Not because it was abandoned and forgotten, but intentionally, carefully, as if whoever did it wanted to protect it from something, or hide it from someone, or preserve it for the future.
For a time when people would have the tools to excavate it and the knowledge to understand what it meant. Maybe they understood something we're only now relearning, that knowledge is fragile, that it can be lost in a single generation if it's not encoded properly, that words spoken aloud vanish with the speaker, that oral traditions mutate over time, becoming myths and legends whose original meaning is obscured, that even writing on clay tablets or papyrus or parchment can burn or crumble or be deliberately destroyed by conquerors who want to erase the past. But stone lasts, especially stone buried under soil, where it's protected from erosion and weathering. And if you align that stone with the stars, if you carve into it the positions of constellations at a specific moment in time, then anyone in the future who understands astronomy and precession can calculate backward and know exactly when the monument was created and what it commemorated. What if the builders of Göbekli Tepe knew that another catastrophe might come? What if they had inherited stories from their ancestors about cycles of destruction, about worlds that had ended before, about the need to preserve knowledge across the abyss of time? And they carved their warning into stone, buried it to protect it, and left it for us to find 11,000 years later, when we would have the technology to excavate it and the astronomical software to decode it. And the question that haunts you as the sun sets behind the hills of southeastern Turkey is this: are we listening? Are we paying attention to what they tried to tell us? Or are we making the same mistake they warned against, building our civilization on the assumption that the world is stable, that the sky is safe, that catastrophe is something that happens to other people in other times, never to us? But if Göbekli Tepe was a message, a warning carved in stone about the sky and the stars and the catastrophe that can come from above, then the question becomes, where are the cities that existed before it? Where are the civilizations that the survivors came from? Because if there were teachers, there must have been a place where they learned. If there were stone-working techniques being transmitted, someone had to develop those techniques first. And the answer, according to some researchers, might be underwater, beneath the seas that rose when the ice melted. Because during the Ice Age, when Göbekli Tepe was being built, sea levels were still rising from their low point 120 meters below current levels, drowning coastlines, flooding river valleys, submerging entire landscapes where humans had lived for thousands of years. And maybe that's where the evidence is, not buried under sand in deserts or jungle in the Amazon, but under 100 meters of seawater, in places we've only just begun to explore with sonar and submersibles. Are you ready to descend beneath the waves? Are you ready to swim through drowned cities and walk along ancient coastlines that haven't seen sunlight in 12,000 years? Because we're about to dive into the cold, dark waters off the coast of India, near the city of Dwarka, off the southern tip of Japan, near Yonaguni Island, into the North Sea, above what was once Doggerland, connecting Britain to mainland Europe, and into the Mediterranean, where entire harbors may lie buried under sediment. And we're going to look at stone structures that rise from the seafloor, structures that some researchers argue look too regular, too geometric, too intentional to be natural formations. And if they're not natural, then they're proof that someone was building sophisticated settlements when the Ice Age was ending and sea levels were rising. And if that's true, then the history we've been taught, the narrative that civilization began with Sumer around 3000 BCE, is missing at least 7,000 years. And those missing millennia might contain answers to questions we're only now learning to ask. The path continues downward, away from the hilltop temple, and toward the drowned worlds, and the water has secrets to tell. Chapter 3. The Drowned Worlds, Cities Beneath the Sea. You're floating 60 feet beneath the surface of the Arabian Sea, 20 nautical miles off the coast of Gujarat in northwestern India. The water is cold at this depth, around 18 degrees Celsius, and murky with suspended sediment carried by currents from the Indus River Delta 200 kilometers to the northwest. Your regulator hisses rhythmically as you descend slowly following the anchor line, and below you, barely visible through the green-tinted water, you can see the outline of something that doesn't belong on a natural seafloor. A wall, straight and deliberate, running parallel to the muddy bottom for what looks like dozens of meters before disappearing into the gloom. It's built from large stone blocks, each one roughly rectangular, fitted together with joints that are too precise, too intentional to be accidents of geology. You reach the bottom at 19 meters depth according to the dive computer strapped to your wrist. Your fins kick up small clouds of silt as you settle onto the seafloor, and you extend your hand to touch the wall. It's rough under your gloved fingers, pocked with barnacles and covered in a thin layer of marine growth. But beneath the biological coating, you can feel the edges, the corners where one block meets another. And at intervals along the wall, there are what look like columns or posts. Cylindrical stone structures rising about 2 meters from the base, eroded smooth by millennia of current, but still recognizably artificial. This isn't a natural formation. You've seen natural rock formations on dives before, weathered cliffs and tide-carved shelves. This is different. This has geometry, intention, purpose. Your dive guide signals for you to follow, and you swim slowly along the length of the wall, your underwater light cutting through the murk, illuminating more structures as you go. Circles of stone that might have been foundations for buildings, their perimeters marked by carefully placed blocks forming rings approximately 8 to 10 meters in diameter. Large rectangular slabs that could have been floors or platforms, lying flat and level despite being submerged for thousands of years. And everywhere, scattered across the seafloor like giant stone donuts, are anchors. Over 50 of them documented in survey reports published by the Archaeological Survey of India in 2001. Each one carved from a single piece of sandstone, shaped into rings with a central hole, weighing between 200 and 400 kilograms, the kind used by ancient ships to moor in harbors. Too many to be from shipwrecks, too concentrated to be random. They suggest a place where many vessels came and went, a port, a harbor, a city by the sea. When you surface 45 minutes later, your head breaking through the choppy waves into the bright Indian sunlight, and you ask your guide where exactly you are, he tells you the name that has haunted Indian mythology for 3,000 years, Dwarka, the legendary city of Lord Krishna described in the Mahabharata, one of the two great Sanskrit epics composed between 400 BCE and 400 CE. According to the text, Dwarka was a magnificent port city built by Krishna on land reclaimed from the sea. It had massive walls made of stone and iron, multiple gates guarded by towers, wide streets laid out in a grid pattern, and a harbor that could accommodate hundreds of ships. The city was said to be so beautiful that it rivaled the palaces of the gods. But after Krishna departed from the mortal world, the ocean reclaimed what had been taken from it, and Dwarka sank beneath the waves in a single day, leaving only legends behind. For centuries, scholars dismissed the story as mythology, beautiful poetry with no basis in reality, the kind of foundation myth that cultures create to explain their origins or glorify their heroes. But in 1963, everything changed when a team of archaeologists, led by the Deccan College in Pune, began exploring the waters near the modern town of Dwarka in Gujarat. And they found structures, stone blocks arranged in patterns, walls extending into the sea, and those distinctive ring-shaped anchors that matched descriptions in ancient texts. Subsequent expeditions by the Archaeological Survey of India in 1979, 1983, and most extensively in 2001, under the direction of marine archaeologist Dr. S.R. Rao, who had previously discovered the Harappan port of Lothal, continued to uncover more evidence using side-scan sonar and underwater photography. In 2001, the National Institute of Ocean Technology, based in Chennai, conducted a major survey using advanced multi-beam sonar that can map the seafloor in 3 dimensions with resolution down to 1 meter. And they found geometric structures, large formations measuring over 40 meters in length that showed regular patterns, straight edges, right-angle corners, features that marine geologists like Dr. Rajiv Nigam from the National Institute of Oceanography in Goa argued were difficult to explain through natural geological processes alone. The structures were located at depths ranging from 8 to 40 meters below current sea level, suggesting they were built when the sea was lower, during or shortly after the last ice age. The dating has been intensely controversial and remains disputed in academic literature. Some researchers, including Dr. S.R. Rao, initially claimed the artifacts could be 9,000 years old, based on the depth at which they were found and calculations of sea level rise rates, which would make these structures older than any known Indian city.
Older than the Indus Valley civilization that flourished around 2500 BCE, with cities like Harappa and Mohenjo-daro. Older even than the earliest Mesopotamian cities. If true, this would completely rewrite the history of South Asian civilization. But other archaeologists, including Dr. A.S. Gower from the National Institute of Oceanography, who has studied the site extensively since 2005, argue for much younger dates, around 3,000 to 4,000 years old, roughly 1,500 to 1,000 BCE, which would place Dwarka in the late Harappan period or early Iron Age, fitting better with the known timeline of urbanization in the region. The debate centers on methodology. Dating underwater sites is extraordinarily difficult because, unlike terrestrial archaeology, where you can use radiocarbon dating on organic materials like charcoal or bone found in clear stratigraphic layers, underwater sites are constantly disturbed by currents. Marine growth covers surfaces, making it hard to assess original construction techniques, and there's often no organic material preserved that can be dated reliably. The stone anchors are typologically similar to ones used in the late Bronze Age, around 1000 BCE, throughout the Mediterranean and Indian Ocean. But similar doesn't mean contemporary. Anchor designs can persist for thousands of years, and without organic material directly associated with the construction of the walls and platforms, assigning a precise date remains speculative. But here's what's undisputed and documented in peer-reviewed papers in journals like Current Science and Marine Archaeology. There are structures underwater off the coast of Dwarka. They include stone walls extending for hundreds of meters, circular and rectangular foundations that look like building platforms, and a concentration of anchors that suggests maritime activity on a significant scale. Whether these are the remains of KRISHNA's mythical city or a later port from the historical period, someone built something there, and the sea took it back, and the presence of these structures lends credibility to the possibility that other coastal settlements from the end of the Ice Age might also lie underwater, waiting to be discovered. Far across the Indian Ocean, on the opposite side of Eurasia, another underwater mystery has sparked equally fierce debate. Off the southern coast of Yonaguni Island, the westernmost inhabited island of Japan, located 125 kilometers east of Taiwan, a local dive tour operator named Kihachiro Aratake was exploring the waters in 1995 when he discovered something that would ignite one of the most contentious controversies in underwater archaeology. Rising from the seafloor at a depth of 25 meters was a massive terraced structure, or formation, depending on which expert you ask. It had broad, flat platforms stacked like steps, the largest measuring approximately 100 meters long and 25 meters wide.
sharp, right-angle corners that looked machine-cut, what appeared to be staircases carved into the rock, with individual steps approximately 20 centimeters high, straight edges forming corridors and channels, and most striking, what looked like partially carved figures and symbols on some of the rock faces. Professor Masaki Kimura, a marine seismologist from the University of the Ryukyus in Okinawa, who holds a PhD in geology from Tohoku University, has spent over 25 years studying the Yonaguni monument, conducting more than 200 dives and publishing his findings in books and papers, including a detailed monograph in 2011. And he is absolutely convinced it's man-made. Kimura points to specific features that he argues cannot be explained by natural erosion. Holes drilled into the stone at regular intervals, approximately 50 centimeters apart, arranged in straight lines, apparently for inserting wooden posts or markers. Straight edges where blocks seem to have been cut and removed from the parent rock using techniques similar to quarrying. Markings on some surfaces that he interprets as symbols or characters, possibly representing animals or abstract designs, and the overall geometry of the structure, which he claims shows planning and architectural intent. Based on the depth at which the monument sits and sea level curves for the region, Kimura dates the structure to approximately 10,000 years ago, during the final stages of the Ice Age, when this area would have been above water, and he suggests it may have been built by the Jomon people, an ancient culture that inhabited the Japanese archipelago from approximately 14,000 BCE to 300 BCE, and developed some of the world's earliest pottery, including cord-marked ceramics dated to 14,500 years ago, from sites like Odai Yamamoto in Aomori Prefecture. But not everyone agrees, and the skepticism from mainstream geology has been vocal and persistent. Professor Robert Schoch, a geologist from Boston University who holds a PhD from Yale and is best known for his controversial redating of the Sphinx in Egypt, examined the Yonaguni monument in person during a diving expedition in 1997, and he concluded that the structure is almost entirely natural, shaped by well-understood geological processes, including tectonic activity and marine erosion. Schoch points to the fact that Yonaguni Island sits in a highly active seismic zone where earthquakes are frequent. The rock is fine mudstone and sandstone from the Miocene epoch, approximately 20 million years old, and these sedimentary rocks naturally fracture along parallel planes when subjected to tectonic stress, creating straight edges and right angles without human intervention. He cites examples of similar natural formations around the world: the Giant's Causeway in Northern Ireland, with its hexagonal basalt columns formed by volcanic cooling, the tessellated pavement at Eaglehawk Neck in Tasmania, Australia, where sedimentary rock has fractured into regular rectangular blocks, and the Tepe formations in Venezuela, where sandstone plateaus have eroded into step-like terraces, all created by natural processes with no human involvement. In Schoch's view, published in articles in Skeptical Inquirer magazine in 2001, the Yonaguni monument is an interesting geological formation, made more dramatic by the human tendency to see patterns and recognize familiar shapes like stairs or platforms in random natural structures, a phenomenon called pareidolia that also explains why people see faces in clouds or the man in the moon. The debate remains unresolved. Both sides have valid points supported by evidence. Kimura can show you the holes and the straight cuts. Schoch can show you natural formations that look equally artificial. Kimura can point to statistical improbability of so many right angles occurring naturally in such a small area. Schoch can explain the geological mechanisms that produce exactly those kinds of fracture patterns in layered sedimentary rock. And without clear evidence of tool marks that are unambiguously artificial, or associated artifacts like pottery or stone tools found in situ, within or around the structure, or organic material that could be radiocarbon dated to establish when humans might have worked the stone, The question of whether Yonaguni is natural or artificial remains open. Frustratingly so for researchers on both sides. But here's the pattern that you can't ignore as you float above these contested stones in the waters off Japan, from the North Sea to the Arabian Sea to the Pacific. Underwater ruins and formations appear at similar depths, roughly 20 to 40 meters below current sea level, which corresponds almost exactly to the coastline as it existed between 12,000 and 8,000 years ago, when sea levels were rising rapidly from their Ice Age low point. They all cluster in the same time period chronologically, the end of the Younger Dryas and the early Holocene, when the great ice sheets were melting and pouring millions of cubic kilometers of water into the oceans, raising sea level by approximately 120 meters over the course of about 8,000 years. That's an average of 1.5 centimeters per year. But the rise was not uniform. There were periods of rapid pulse melting called meltwater pulses when ice dams failed catastrophically. Meltwater Pulse 1A occurred around 14,600 years ago and raised global sea level by 16 to 25 meters in less than 500 years, according to coral reef data from Barbados analyzed by Richard Fairbanks from Columbia University. That's 4 centimeters per year, fast enough to be visible within a human lifetime, fast enough to flood coastal settlements and force populations to retreat inland. Meltwater Pulse 1B, around 11,300 years ago, added another 15 meters, and there may have been other smaller pulses in between that we haven't yet identified in the geological record. For people living on coastlines during these periods, the changes would have been catastrophic. Villages flooded, agricultural lands submerged, harbors becoming unusable as the water rose year after year, generation after generation, and eventually those who stayed too long were overtaken, their cities drowned, their monuments submerged, their evidence of existence erased beneath the waves. Let's move west now, across the Indian Ocean and through the Suez Canal into the Mediterranean. But before we get there, we need to stop in the North Sea, in the cold waters between Britain and mainland Europe, because beneath those gray waves lies one of the most extraordinary lost worlds ever discovered, a place called Doggerland. During the last ice age, when so much of Earth's water was locked in glaciers covering Canada and Scandinavia, sea levels were 120 meters lower than today, and what is now the North Sea was dry land. A vast territory of marshes, rivers, forests, and grasslands stretching from eastern England to Denmark and the Netherlands, covering an area of approximately 100,000 square kilometers, larger than Portugal. And it was home to thriving communities of Mesolithic hunter-gatherers who built settlements, hunted aurochs and red deer, fished in rivers that no longer exist, and lived lives that left almost no trace, because everything they built is now underwater. We know Doggerland existed because fishermen trawling the North Sea for cod and herring have been pulling up evidence for over a century. Bones of mammoths and woolly rhinoceroses, antlers of giant elk with spans reaching 3.6 meters, stone tools, including hand axes and microliths, harpoon points carved from bone, and occasionally, heartbreakingly, human remains. In 1931, a fishing trawler working 40 kilometers off the coast of Norfolk, England, brought up a barbed antler point, a hunting tool that was radiocarbon dated to around 11,800 years ago. In 1998, a Neanderthal skull fragment was recovered from waters near Rotterdam, and in 2010, amateur archaeologist Jan Glimmerveen, who has been collecting artifacts from North Sea fishermen for decades, recovered a fragment of human skull bone from sediment dredged near the Zeeland ridges that dated to approximately 7,000 years ago. In recent decades, seismic surveys conducted by oil companies looking for petroleum deposits beneath the North Sea have inadvertently provided archaeologists with detailed maps of Doggerland's topography. The same technology used to image rock layers thousands of meters below the seafloor can also map the surface. And researchers at the University of Bradford in England, led by archaeologist Vince Gaffney, have used this data to create three-dimensional reconstructions of the landscape as it appeared 9,000 years ago. The images show river valleys cutting through rolling hills, lake systems, including one large lake called the Outer Silver Pit that covered over 3,000 square kilometers, marshlands along the coasts, and what appear to be possible settlement sites on elevated ground near water sources, exactly where you'd expect hunter-gatherer communities to establish camps. Doggerland didn't disappear overnight. It shrank gradually as the seas rose over thousands of years. By around 9,000 years ago, it had been reduced to a series of low-lying islands, and then, around 6,200 BCE, approximately 8,200 years ago, it was finished off by a catastrophic event called the Storegga Slide. This was a massive submarine landslide off the coast of Norway, where approximately 3,000 cubic kilometers of sediment on the continental slope became unstable, possibly triggered by an earthquake, and slid into the deep ocean basin. The displacement of that much material generated a tsunami, with waves estimated by marine geologist David Long from the British Geological Survey to have reached heights of 25 meters in the Shetland Islands and 10 to 15 meters along the coasts of Doggerland, Scotland, and Norway.
Geological evidence of the Storegga tsunami has been found inland in Scotland, where sand deposits containing marine microfossils appear at elevations up to 6 meters above current sea level, in locations like Montrose Basin and the Firth of Forth, dated using radiocarbon to approximately 6,200 BCE for the last inhabitants of Doggerland, if there were any still living on the remaining islands at that time. This tsunami would have been apocalyptic. Entire communities could have been swept away in minutes, leaving no trace except possibly in oral traditions, stories of a great wave that destroyed the world. Stories that might have been passed down through generations and eventually transformed into the flood myths we find across European cultures. And after the tsunami, the remaining fragments of Doggerland were completely submerged, becoming what we now call the Dogger Bank, a shallow sandbank in the North Sea where fishing trawlers still occasionally net artifacts from the lost world below. Some researchers, including author Graham Hancock and geologist Paul Dunbavin, have called Doggerland the Atlantis of the North, suggesting that Plato's story of a powerful island civilization that sank beneath the sea might actually be a corrupted memory of Doggerland, transmitted through ancient trade routes and oral traditions, morphing over thousands of years from a real place into a myth. While mainstream archaeologists consider this highly speculative, the parallel is striking. A large inhabited landmass that existed during the late Ice Age supported a substantial population with established culture and trade networks, as evidenced by the diversity of tools and the presence of materials like flint from sources hundreds of kilometers apart, and then disappeared beneath the sea, leaving only scattered artifacts and vague memories. The question that haunts researchers is this: how many other Doggerlands are there? How many other inhabited landscapes were drowned when the ice melted? Because Doggerland was just one relatively small section of the continental shelf that was exposed during low sea levels. Globally, approximately 20 million square kilometers of land was above water during the Ice Age that is now submerged. That's an area larger than Russia, and much of it was prime real estate for early humans. Coastal plains with access to both marine and terrestrial resources. River valleys with fresh water and fertile soil, areas where you'd expect to find the highest population densities, and all of it is now underwater, unexplored, unmapped, its secrets buried under sediment and sea. Maybe the ocean didn't just take land when the ice melted, maybe it took memory. Because when entire coastlines flood over the course of centuries, when villages disappear beneath rising waters, when people are forced to migrate inland, abandoning everything they built, the knowledge of what existed before begins to fade. Within a few generations, the drowned cities become stories, the stories become myths,
and the myths become fantasies that historians dismiss as imagination. But what if the myths are memories, corrupted and distorted by time and retelling, but memories nonetheless? Memories of real places that really sank, real civilizations that really existed before the flood. And if that's true, then how much of human history are we missing? How much of our story is still down there, waiting in the dark waters to be discovered? But here's the deeper question that follows you as you surface from these dives and strip off your wetsuit and stand on the deck of the research vessel, looking out at the horizon where sea meets sky. If these drowned cities are real, if coastal civilizations did exist during the Ice Age and were destroyed by rising seas, then there's one legend that refuses to die. One story that has haunted human imagination for over 2,000 years. A story told by the Greek philosopher Plato about an empire that sank beneath the sea in a single day and night. And maybe, just maybe, it wasn't a story at all. Maybe it was history, corrupted by time, but pointing towards something real, something we're only now beginning to find beneath the waves. And that story, that name that everyone knows but no one can prove, is Atlantis. And that's where we're going next, into the myth, into the evidence, into the possibility that the greatest mystery of the ancient world might actually be the greatest truth we've forgotten. Chapter 4. Atlantis, the memory hidden in myth. You're standing in a sunlit courtyard in Athens, 360 years before the Common Era. The year is 360 BCE, and you're listening to an old philosopher named Plato, who is now in his late 60s. His voice is calm and measured, the way teachers speak when they want you to remember every word, not rushed or dramatic, but weighted with significance. And he's telling a story that will haunt humanity for the next 23 centuries. He begins with a simple statement. This is not a fable. This is not an invention of my mind. This is a true account passed down from Solon, who heard it from Egyptian priests in the city of Sais during his travels to Egypt 230 years ago. And those priests, Plato says, kept records that went back 9,000 years before Solon's time, carved into stone pillars in their temples, preserving the memory of events that the Greeks had long forgotten. The story goes like this. Beyond the Pillars of Hercules, which is the ancient name for the Strait of Gibraltar, where the Mediterranean Sea opens into the Atlantic Ocean, there was an island, larger than Libya and Asia Minor combined, which in ancient Greek geographic understanding meant a landmass of extraordinary size, possibly comparable to the Iberian Peninsula or larger. And on that island was a civilization called Atlantis, named after the god Atlas, who in Greek mythology held up the sky. The Atlanteans, according to Plato, writing in his dialogues Timaeus and Critias, were powerful. They ruled not only their own island, but vast territories beyond it. They had conquered parts of Europe as far as Tyrrhenia, which is roughly modern-day central Italy, and parts of Africa as far as the borders of Egypt. Their armies were formidable, their navy controlled the seas, and their ambition seemed unlimited. They even launched a campaign to conquer the Mediterranean world, including Athens itself. But the Athenians, Plato says with obvious pride in his city's mythical past, resisted the Atlantean invasion. They fought with courage and skill, and despite being outnumbered, they defeated the Atlantic forces and preserved the freedom of the Mediterranean peoples. However, this victory was short-lived, because shortly after the war ended, catastrophe struck. Plato's exact words, as recorded in the Timaeus, translated from ancient Greek, are, "There occurred violent earthquakes and floods, and in a single day and night of misfortune, all your warlike men in a body sank into the earth, and the island of Atlantis in like manner disappeared into the depths of the sea." The timeline Plato gives is specific. This destruction occurred 9,000 years before Solon's visit to Egypt, around 594 BCE, which places the sinking of Atlantis at approximately 9,600 BCE. And here's what makes scholars nervous even today. That date is remarkably close to the end of the Younger Dryas period, at approximately 9,600 BCE, when, as we discussed in the first chapter, the Earth's climate was undergoing catastrophic changes. Ice sheets were collapsing, sea levels were rising rapidly, and entire landscapes were being transformed. For Plato, who was primarily a philosopher interested in questions of justice, governance, and the ideal state, the story of Atlantis served a clear purpose. It was a moral lesson, a warning about hubris and the dangers of a civilization that grows too powerful and loses its virtue. The Atlanteans started as a noble people, blessed by the gods with a rich land and advanced knowledge. But over generations they became corrupted by wealth and ambition. They grew arrogant, aggressive, and morally degenerate. And the gods punished them for their hubris by destroying their entire civilization in a single catastrophic event. It's a classic Greek narrative, the rise and fall of those who forget the limits of mortal power. Similar to the stories of Icarus flying too close to the sun, or Prometheus stealing fire from the gods. But here's the question that has divided scholars for over 2,000 years. Was Plato inventing a philosophical allegory, using a fictional lost civilization as a thought experiment to explore ideas about political systems and moral decay? Or was he relaying fragments of a real historical event, a genuine memory preserved by Egyptian priests who, as he claimed, kept records stretching back thousands of years into the deep past? The academic consensus has long been that Atlantis was fiction. Plato's student Aristotle, who studied at the Academy in Athens for 20 years, reportedly said that Plato created Atlantis and then destroyed it, implying it was a literary device, not a historical account. And most classicists, including Professor Christopher Gill from the University of Exeter, who has written extensively on Plato's dialogues, argue that the story has all the hallmarks of an invented parable, too perfectly structured, too morally neat, too convenient as a vehicle for Plato's philosophical arguments about the ideal state. Yet there are details in Plato's account that feel strangely specific for pure fiction. He describes the geography of Atlantis with precision. The island had a central plain that was rectangular, measuring 3,000 stadia by 2,000 stadia, which converts to approximately 550 kilometers by 370 kilometers, using the Attic stadium of 185 meters. The plain was surrounded by mountains that sheltered it from northern winds. There were 2 springs on the island, one of cold water and one of hot water, suggesting volcanic activity. The capital city was built in concentric rings, alternating circles of land and water connected by bridges and canals. The outermost ring of water was wide enough for large ships to sail through and reach the inner harbor, and the rings of land were surrounded by walls. The outer wall covered in brass, the middle wall coated in tin, and the innermost wall around the citadel sheathed in orichalcum, a mysterious red metal that Plato says gleamed like fire and was second in value only to gold. At the center of the city stood a great temple dedicated to Poseidon, the god of the sea, and according to the myth, the divine ancestor of the Atlantean royal line. The temple's exterior was covered in silver and its pinnacles in gold. Inside was a massive statue of Poseidon, standing in a chariot pulled by winged horses, so large that his head touched the roof of the temple. Plato describes the wealth of Atlantis in detail. They had abundant natural resources, including a mysterious metal that could be mined from the earth. They grew 2 harvests per year thanks to the fertility of their soil. They had both wild and domesticated animals, including elephants, which suggests a warm climate. They built aqueducts, bridges, and harbors, and their population was large enough to field armies numbering in the tens of thousands. These details, especially the concentric ring structure of the capital city,
have inspired countless attempts over the past 2 millennia to locate Atlantis. If it was real, where was it?
Plato says, "Beyond the Pillars of Hercules, which most scholars interpret as west of Gibraltar in the Atlantic Ocean, and this has led to numerous theories placing Atlantis in the open Atlantic. The most enduring location proposed is the Azores, a group of 9 volcanic islands belonging to Portugal that rise from the mid-Atlantic ridge approximately 1,500 kilometers west of Lisbon. The theory, popularized in the late 19th century by American congressman and amateur archaeologist Ignatius Donnelly in his book Atlantis, The Antediluvian World, published in 1882, suggests that the Azores are the mountain peaks of a larger landmass that was partially submerged when sea levels rose at the end of the Ice Age. Donnelly's book was enormously influential. It sold millions of copies and inspired generations of Atlantis hunters. He argued that Atlantis was the original source of all civilization, that survivors from the island carried their advanced knowledge to both sides of the Atlantic, seeding the cultures of ancient Egypt, Mesopotamia, and Mesoamerica, which would explain, according to his theory, the similarities in pyramid building, astronomical knowledge, and flood myths found in these geographically separated civilizations. However, geological evidence has thoroughly debunked the Azores theory. Marine surveys of the seafloor around the islands conducted by oceanographic institutions, including the Lamont Doherty Earth Observatory at Columbia University, show that the Azores have been volcanic peaks rising from the ocean floor for millions of years. There is no submerged continent, no drowned land mass, no evidence of human habitation before Portuguese settlers arrived in the 15th century CE. The timeline doesn't work. The geology doesn't work. And the Azores can be definitively ruled out as the location of Atlantis, if Atlantis existed at all. A more speculative and, frankly, implausible theory places Atlantis in Antarctica. This idea gained traction in part because of early modern maps, particularly the Piri Reis map, created by Ottoman Admiral Piri Reis in 1513 CE, which some researchers, including Professor Charles Hapgood from Keene State College in New Hampshire, argued in his book Maps of the Ancient Sea Kings, published in 1966, shows the coastline of Antarctica as it might have appeared before it was covered by ice. Hapgood proposed that the map was copied from much older source maps dating back thousands of years, possibly to a time when Antarctica was ice-free and inhabited. The theory suggests that during the Ice Age, parts of Antarctica might have been habitable, hosting an advanced society that was later buried when the ice sheets expanded. This idea has been enthusiastically adopted by some alternative history writers, including Rand Flemath and Rose Flemath in their book When the Sky Fell, published in 1995, and more recently by Graham Hancock, who dedicates significant discussion to Antarctica in his book Fingerprints of the Gods. However, mainstream science has rejected this theory completely. Glaciological studies using ice cores drilled by the Antarctic ice coring programs, including the European Project for Ice Coring in Antarctica and the West Antarctic Ice Sheet Divide Project, show that Antarctica has been heavily glaciated for at least 34 million years. The continent was already covered in ice sheets averaging 2 kilometers thick long before humans evolved. There was no ice-free period during the time frame Plato describes, or any time in the past several million years when human civilization could have existed there. The Piri Reis map has been explained by cartographic historians as showing the coast of South America, not Antarctica, with distortions typical of 16th century map-making techniques. And the Antarctica-Atlantis theory can be safely dismissed as geologically impossible. A third and visually compelling theory points to the reshaped structure in Mauritania, also known as the Eye of the Sahara. This massive circular geological formation is located in the Sahara Desert, approximately 450 kilometers from the Atlantic coast. It measures approximately 40 kilometers in diameter and consists of concentric rings of exposed rock layers. When viewed from space or high altitude, it looks like a giant bullseye carved into the desert. The resemblance to Plato's description of Atlantis, with its alternating rings of land and water, is striking, and this similarity has led some researchers, including YouTube content creators and alternative history enthusiasts, to propose that the rechat structure is the true location of Atlantis. The theory, as presented by researcher Jimmy Bright and others, suggests that during the Ice Age, when the Sahara was much greener and wetter than today, a period called the African Humid Period that lasted from approximately 15,000 to 5,000 years ago, when the region received significantly more rainfall and supported lakes, rivers, and savanna ecosystems. The rechat structure might have been the center of a thriving civilization. The concentric rings could have been natural formations that the Atlanteans enhanced with walls and canals, and the city could have been destroyed not by sinking into the ocean, but by desertification and possibly a catastrophic flood when climate patterns shifted. Proponents point to the fact that the structure is the right size, matching Plato's dimensions quite closely. It has evidence of ancient water channels, and it's located in West Africa, which could be interpreted as beyond the Pillars of Hercules if you sailed south along the African coast. However, geologists have thoroughly studied the reshot structure, and their consensus, published in journals including the Journal of African Earth Sciences, is unambiguous. The formation is the result of natural erosion, specifically a geological dome that formed approximately 100 million years ago during the Cretaceous period, was gradually eroded by wind and water over millions of years, exposing the concentric layers of different rock types, quartzite, limestone, dolomite, that eroded at different rates, creating the circular pattern. There is no evidence of artificial construction, no building foundations, no artifacts, no tools, nothing to suggest human habitation in the deep past. Archaeologist Dr. Robert M. Schock, who examined the site, stated that while it's visually striking, it's entirely natural and cannot be connected to Atlantis without abandoning all geological evidence. So, if Atlantis wasn't in the Atlantic, wasn't in Antarctica, and wasn't in the Sahara, then where was it? Or, more importantly, what was it? Here's an interpretation that's worth considering. What if Plato's Atlantis wasn't one specific place, but a composite memory? A story that merged multiple real events, multiple sunken cities, multiple coastal catastrophes from the end of the Ice Age into a single symbolic narrative. Because, as we saw in the previous chapter, there were drowned cities, Doggerland connecting Britain to Europe, submerged by rising seas, and finished off by the Storegga tsunami. Coastal settlements in the Persian Gulf flooded when meltwater from the Zagros Mountains raised water levels. The Sunda Shelf, connecting Southeast Asia to Indonesia and Malaysia, went underwater, drowning river valleys and plains. Entire coastlines around the Mediterranean, the Black Sea, the Indian Ocean, all of them transformed by sea level rise between 10,000 and 6,000 BCE. From this perspective, Atlantis becomes not a single lost city, but the name we gave to a universal human experience, the memory of a world before the flood, a time when the coastlines were different, when land that is now underwater was inhabited, when civilizations rose and were drowned by forces beyond their control. And these memories were preserved in myths, passed down through oral traditions, eventually reaching the Egyptian priests, who told Solon, who told Plato, and by the time Plato wrote it down 8,000 years after the event supposedly occurred, the details had been distorted, compressed, mythologized, but the core truth remained. There was a world before this one, and the sea took it. And if that's true, then Atlantis is everywhere. It's Dwarka off the coast of India. It's the structures at Yonaguni near Japan. It's Doggerland under the North Sea. It's the villages on the Black Sea shelf that were flooded when the Mediterranean broke through the Bosporus around 5,600 BCE in an event called the Black Sea Deluge hypothesis, proposed by marine geologists William Ryan and Walter Pittman from Columbia University. It's every coastal settlement that didn't retreat fast enough when the waters rose. But if floods erased these cities, if entire coastlines were drowned, and their evidence scattered across the seafloor under 100 meters of water, then who survived to tell the story? Who carried the memory forward? And more importantly, who carried the knowledge? Because if there's one pattern that appears again and again in myths from cultures around the world, it's the arrival of teachers after the flood. Civilizers who appear from nowhere, often described as coming from across the sea, and they bring gifts, the knowledge of agriculture, the secrets of astronomy, the techniques of building in stone, the laws of governance, and they're remembered not as human, but as gods. And that's where we're going next, into the myths of the survivors, into the stories of the teachers, into the possibility that the gods of ancient legend were real people, refugees from a drowned world, carrying fragments of a lost civilization into the next age. And if that's true, then the question becomes, what did they know? What were they trying to preserve?
And are we ready to remember what they tried to teach us? Chapter 5. The Survivors. Gods Who Walked After the Flood. You're walking through the ruins of Uruk, one of the world's first cities located in what is now southern Iraq, approximately 300 kilometers southeast of modern Baghdad. The sun is brutal at midday, the air shimmers with heat rising from the sand, and beneath your feet are the foundations of a civilization that appeared almost overnight in archaeological terms, around 4000 BCE, roughly 6,000 years ago. This is where writing was born, where the first complex urban societies emerged, where humanity made the leap from scattered farming villages to organized city-states with populations numbering in the tens of thousands. Archaeologists call this transformation the urban revolution, and it happened here in Mesopotamia, in the fertile land between the Tigris and Euphrates rivers. But what they struggle to explain is why it happened so fast. You kneel down and pick up a pottery shard from the ground. It's covered in wedge-shaped marks, cuneiform, the earliest known writing system developed by the Sumerians around 3200 BCE. Fully formed, not primitive scratches or simple pictographs that gradually evolved into complex symbols, but a sophisticated script capable of recording not just inventory lists and trade transactions, but poetry, legal codes, astronomical observations, and literary epics like the story of Gilgamesh, composed around 2100 BCE. Nearby, scattered among the ruins, are clay tablets inscribed with mathematical calculations using a base 60 number system, the same system we still use today for measuring time in minutes and seconds and angles in degrees, developed by Sumerian scribes who understood place value and could perform complex multiplication and division. The engineering visible in the excavated structures is equally impressive. The White Temple, built on a massive platform called a ziggurat, around 3000 BCE, rises in stepped levels, each one precisely aligned to the cardinal directions, with an accuracy within 1 degree. Constructed from millions of mud bricks, each weighing approximately 11 kilograms, requiring organizational capacity to manage thousands of workers, supply chains to provide food and materials, and architectural knowledge to create structures that have survived 4,000 years of weather and war. And this is just one city. Across Mesopotamia during the same period, similar cities were rising. Ur, Lagash, Eridu, Nippur, each with temples, irrigation systems, administrative buildings, craft workshops, all appearing within a few centuries of each other between 4000 and 3000 BCE. From a conventional academic standpoint, articulated by archaeologists like Norman Yoffe from the University of Michigan in his book Myths of the Archaic State, published in 2005, this rapid development can be explained as the natural result of favorable environmental conditions. The Tigris and Euphrates rivers flooded annually, depositing nutrient-rich silt that made agriculture extraordinarily productive. Surplus food meant population growth.
Population density encouraged specialization, where some people could focus full-time on pottery or metalworking or administration rather than farming. Specialization led to social stratification, with priests and rulers emerging as an elite class. The need to manage irrigation systems and resolve disputes created demand for written records and formal laws. And innovation built upon innovation in a positive feedback loop until you had cities. It's a logical progression documented in the archaeological record through thousands of excavated sites across Iraq, Syria, and southeastern Turkey studied over the past century by institutions including the Oriental Institute at the University of Chicago and the British Museum. We can trace the development from the Ubaid period, around 5500 BCE, when the first temples appear, through the Uruk period, starting around 4000 BCE, when cities emerge, into the early dynastic period, beginning around 2900 BCE, when writing becomes widespread. The timeline is clear, the material evidence is there, pottery styles evolve, architectural techniques improve, settlement sizes grow. It all makes sense as a gradual cultural evolution. But here's what makes some researchers uncomfortable: the suddenness, the clustering of innovations. Within a span of about 1,000 years, between 4000 and 3000 BCE, the Sumerians developed writing, mathematics, astronomy sophisticated enough to track planetary movements and predict eclipses, bronze metallurgy requiring knowledge of how to smelt copper and tin and combine them in the correct ratio of roughly 90% copper to 10% tin, monumental architecture with precise alignments, legal codes like the Code of Ur-Nammu from approximately 2100 BCE, which predates the more famous Code of Hammurabi by 3 centuries, wheeled vehicles appearing around 3500 BCE, and complex irrigation networks, including canals spanning dozens of kilometers that required surveying skills and coordinated labor. All of this appears in a relatively compressed time frame, and while you can argue that innovation accelerates once certain thresholds are crossed, the speed is still striking. And then there's what the Sumerians themselves said about their origins. In their own texts, they didn't claim to have invented civilization. They said it was given to them. The Sumerian king list, compiled from multiple clay tablet sources, including the Weld-Blundell prism housed in the Ashmolean Museum at Oxford University, begins with a remarkable statement. When kingship was lowered from heaven, the kingship was in ERASURE.
It then lists kings who ruled before the flood, with reign lengths that are impossibly long. One king named Alulim supposedly ruled for 28,800 years. Another named Dumuzid, the shepherd, for 36,000 years. Clearly, these aren't meant to be literal historical records, but they preserve something important: the idea that there was a world before the flood, that kingship and civilization existed in that earlier world, and that after the flood destroyed everything, the gods re-established civilization by teaching the survivors. In Sumerian mythology recorded in texts like the Eridu Genesis, dating to approximately 1600 BCE, the gods created humans to work the land and serve them. The chief god Enlil became disturbed by the noise humans made. Their cities had grown too large, their populations too numerous, so he decided to destroy humanity with a great flood. But the god Enki, who had created humans, took pity on them and warned a man named Ziusudra, who some scholars identify as the Sumerian prototype for the later Akkadian figure Utnapishtim and the biblical Noah. Enki instructed Ziusudra to build a large boat, seal it with bitumen, and bring aboard his family and representatives of all living creatures. The flood came, lasting 7 days and nights. The waters rose and covered the earth, and when it finally receded, Ziusudra's boat came to rest on a mountain. After the flood, according to these texts, the gods re-established order. They gave humanity the knowledge needed to rebuild civilization, and this pattern of divine instruction appears throughout Sumerian literature.
The god Enki is credited with organizing the world, assigning responsibilities to other deities, establishing the arts and crafts, giving humanity the Mies, which were divine decrees or principles that governed everything from kingship and priesthood to metalworking and music.
In a text called Enki and the World Order, from approximately 2100 BCE, Enki travels through Mesopotamia, establishing cities, digging canals, appointing gods to oversee various domains, bringing order out of chaos. Now here's where it gets interesting. If you step back from the religious interpretation and look at these myths as possible cultural memories, as stories that preserve distorted recollections of real historical events, a different picture emerges. What if the gods weren't supernatural beings, but human survivors of the younger Dryas catastrophe we discussed in the first chapter? People who lived through the floods and climate collapse at the end of the Ice Age, around 9600 BCE, who preserved fragments of knowledge from an earlier culture, and who then appeared to scattered groups of hunter-gatherers in places like Mesopotamia, teaching them skills that seemed miraculous: agriculture, irrigation, architecture, astronomy, metalworking. To a community of people living in temporary shelters, subsisting on wild plants and small game, someone who understood crop cultivation, who could predict seasonal floods by tracking the stars, who knew how to fire clay into pottery or smelt metal from ore, would indeed seem godlike. The technological gap would be so vast that supernatural explanations might be the only framework available to interpret what they were seeing. And over thousands of years of retelling, these teachers would be transformed in cultural memory from human to divine, their real origins forgotten, their achievements attributed to supernatural powers, but the core memory would remain. That knowledge came from outside, that civilization was taught, that someone showed us how. Graham Hancock has built much of his research career on this interpretation, in books including Fingerprints of the Gods, published in 1995, Magicians of the Gods, from 2015, and America Before, released in 2019, he argues that an advanced Ice Age civilization was destroyed by the Younger Dryas impact event. Survivors scattered across the globe carrying their knowledge, and they became the civilizers remembered in mythology. He points to the fact that similar stories appear worldwide, not just in Mesopotamia, but across continents and cultures that supposedly had no contact with each other. In Mesoamerica, the Maya and Aztec traditions speak of Quetzalcoatl, the feathered serpent god, depicted in art and sculpture throughout Mexico and Central America, described in the Florentine Codex, compiled by Spanish friar Bernardino de Sahagún in the 16th century as a bearded man. Unusual because indigenous Mesoamericans typically had little facial hair, who appeared after a great catastrophe and taught the people agriculture, astronomy, mathematics, and the calendar. He showed them how to grow maize, how to track the movements of Venus, which was crucial to Mayan astronomy, how to build temples and pyramids, and how to organize society with laws and rituals. When his work was done, he departed, promising to return someday. In South America, the Inca preserved legends of Viracocha, sometimes called Kon-Tiki Viracocha, described by Spanish chronicler Pedro Cieza de León in 1553 as a white-skinned, bearded man who appeared after a great flood that destroyed the previous world. He emerged from Lake Titicaca, which sits at 3,812 meters elevation on the border between Peru and Bolivia. He created the sun, moon, and stars. He fashioned humans from stone at Tiwanaku, a mysterious archaeological site with massive megalithic structures, including the Gateway of the Sun, carved from single blocks of andesite weighing over 10 tons, and he traveled throughout the Andes teaching people how to farm, build, and live in peace, eventually walking into the Pacific Ocean and disappearing. In ancient Egypt, the traditions are more fragmented, but still present. Texts, including the Turin King List and writings by the historian priest Manetho,
from the 3rd century BCE, describe the Tepe, the first time, an era when gods ruled Egypt directly before the historical pharaohs. These gods, including Osiris, Thoth, and Horus, were credited with giving Egypt the arts of civilization. Osiris taught agriculture and law. Thoth invented writing, mathematics, and astronomy. And they were described as coming from across the waters, from a place called Punt, or from the sea. After a time of chaos and destruction, they brought order, built the first temples, and established Ma'at, the principle of cosmic order and justice that governed Egyptian civilization for 3,000 years. In Polynesia, scattered across the Pacific Ocean, islanders who were separated by thousands of kilometers of open water nevertheless share similar legends of a culture hero named Maui, in Hawaiian, Maui in Maori, who taught navigation, fishing, and agriculture. He slowed the sun to lengthen the day. He pulled islands up from the sea floor with a magical fishhook. He stole fire from the gods and gave it to humans. And, like Prometheus in Greek mythology, who also stole fire for humanity and was punished for it, Maui represents the figure who brings knowledge and technology from a divine or hidden source. Now, the mainstream academic response to this pattern of global flood myths and teacher gods has traditionally been diffusionism versus independent invention. Either these stories spread from a single origin through cultural contact, migration, and trade over thousands of years, or they arose independently because certain human experiences are universal. Floods happen everywhere. All agricultural societies develop origin myths explaining how they learned to farm. The teacher figure is a common archetype in human psychology, representing the transmission of knowledge across generations,
and seeing patterns of similarity doesn't prove historical connection. Anthropologist Claude Lévi-Strauss, in his work on structural anthropology, argued that myths from different cultures share common structures because the human mind works in similar ways, regardless of geography. We create stories to explain the world, using binary oppositions like chaos versus order, nature versus culture. And these fundamental structures appear across mythologies, not because of historical diffusion, but because of shared cognitive architecture. From this perspective, the fact that cultures worldwide tell flood stories just reflects the fact that floods are terrifying and memorable events that all societies experience and incorporate into their mythology. But here's what's harder to explain away: the specific technical knowledge embedded in these myths. The Sumerian god Enki doesn't just give generic wisdom, he teaches specific techniques: canal irrigation, metallurgy, astronomical observation, using the positions of stars to create calendars. Quetzalcoatl doesn't just appear and say, "Be good to each other." He brings the Venus tables, complex mathematical calculations tracking the 584-day synodic period of Venus with an accuracy that requires generations of systematic observation. Thoth, in Egyptian tradition, is credited with a 365-day calendar and knowledge of the precession of the equinoxes, the 26,000-year wobble of Earth's axis that causes the position of stars to shift slowly over centuries. Understanding precession requires continuous astronomical observation over thousands of years, far longer than any individual lifetime. If these gods were just metaphors or archetypes, why do they all teach the same specific technical skills? Astronomy, agriculture, architecture, metalworking, and why do these skills all appear suddenly in the archaeological record within a relatively narrow time window between 5000 and 3000 BCE across different regions? Mesopotamia develops writing. Egypt develops hieroglyphs. The Indus Valley develops its own script, all within about 1,000 years of each other. That could be coincidence, independent invention driven by similar social and economic pressures, or it could suggest contact, knowledge transfer, a shared source.
Hancock's theory is that the source was the Ice Age civilization destroyed by the younger Dryas. Survivors became the teachers, the gods of mythology. But where's the physical evidence? Where are the cities, the artifacts, the technology that would prove an advanced pre-flood culture existed? His answer? The same answer he's given in dozens of debates and interviews, is that the evidence was destroyed. Floods erased coastal settlements, rising seas drowned cities, ice sheets advancing across Canada and Scandinavia crushed everything beneath them. Wildfires from comet impacts burned organic materials, and after 12,000 years of erosion, earthquakes, volcanic activity, and human development building new cities on top of old ruins, what survived are fragments, anomalies, myths, and monuments. Maybe every myth of the flood is a memory, and every god is a teacher we forgot was human. Maybe the real lesson isn't that we need divine intervention to progress, but that knowledge is incredibly fragile, that it can be lost in a single generation if the people who carry it die without passing it on. That writing was invented not just for record-keeping, but as insurance against forgetting. That the survivors of the younger Dryas, whoever they were, understood this better than we do. They'd seen knowledge destroyed, watched their world burn and drown, and when they emerged from the catastrophe, they didn't just rebuild, they encoded, they taught. They carved their wisdom into stone and aligned it with stars. And maybe that's what Göbekli Tepe was, what the pyramids are, what monuments around the world are trying to tell us. That civilizations rise and fall, that catastrophe is cyclical, that the only way to preserve knowledge across the abyss of time is to encode it in forms that outlast words, languages, empires. And that brings us to the question that haunts every researcher who looks at ancient monuments with fresh eyes. If the survivors encoded their knowledge, where did they put it? What did they build? And how do we read what they wrote in stone and stars? Chapter 6. The Star Knowledge. Monuments that remember the sky. You're standing on the Giza Plateau, just outside Cairo. The sun is setting behind you, casting long shadows across the desert sand. And in front of you, the Great Pyramid rises against the darkening sky, perfectly aligned to true north with an accuracy of 3 arc minutes, which is 1/20th of a single degree. A level of precision that modern engineers using GPS and laser theodolites find difficult to match. The pyramid was built approximately 4,500 years ago, around 2,560 BCE, during the reign of Pharaoh Khufu, according to Egyptologist Mark Lehner from the Oriental Institute, who has spent 4 decades studying Giza. Constructed from an estimated 2.3 million limestone blocks, each weighing on average 2.5 tons, some of the granite blocks in the King's Chamber weigh up to 80 tons and were transported from Aswan quarries 800 kilometers to the south. But the alignment is what makes your skin prickle. The Great Pyramid's north face points to true north, not magnetic north, which shifts over time due to changes in Earth's magnetic field, but true north, the axis around which the planet rotates. Achieving this alignment without modern instruments requires astronomical observation, specific tracking the movement of circumpolar stars that never set below the horizon, stars like Thuban in the constellation Draco, which was the pole star approximately 4,500 years ago due to the precession of Earth's axis. The builders would have needed to observe these stars over multiple nights, calculate their circular path, and determine the exact center point, a technique requiring mathematical sophistication and systematic observation. You walk to the eastern edge of the plateau and look out across the Nile Valley, trying to imagine what this place looked like when the pyramids were new, covered in white Tura limestone that reflected the sun like mirrors. And you think about the pattern that researcher Robert Bauval noticed in 1983 while working as a construction engineer in Saudi Arabia. He observed that the 3 main pyramids at Giza, Khufu, Khafre, and Menkaure, are not arranged in a perfectly straight line. The smallest pyramid, Menkaure, is offset slightly to the east, and this offset bothered him because Egyptian architects were obsessed with symmetry and alignment. They wouldn't make a mistake like that unless it was intentional. And then one night, while stargazing in the Arabian desert, Bauval looked up at Orion's belt. 3 bright stars arranged in a diagonal line, with the smallest star, Mintaka, offset slightly to the east, exactly matching the layout of the Giza pyramids. This observation became the foundation of what Bauval called the Orion correlation theory, published in his book The Orion Mystery, co-authored with Adrian Gilbert in 1994. The theory proposes that the entire Giza complex is a terrestrial map of the constellation Orion as it appeared around 10,500 BCE, not when the pyramids were built, but thousands of years earlier. Bauval argues that the pyramids were positioned to commemorate or encode a specific moment in the precession cycle, when Orion reached its lowest point in the sky. A moment that, according to computer simulations using astronomical software like Starry Night and Stellarium, occurred approximately 12,500 years ago, remarkably close to the beginning of the Younger Dryas period we discussed in the first chapter. Mainstream Egyptologists, including Zahi Hawass, who served as Egypt's Minister of Antiquities, and archaeologist Mark Lehner, have been skeptical of this theory. They point out that correlation doesn't prove causation. The fact that 3 pyramids happen to match the pattern of 3 stars could be coincidental, and there's no textual evidence from ancient Egypt stating that the pyramids were meant to represent Orion's belt. However, other researchers, including astronomer Dr. Ed Krupp, director of the Griffith Observatory in Los Angeles, have noted that the ancient Egyptians did associate the constellation Orion with Osiris, the god of death and resurrection, and that the southern shaft in the king's chamber points directly at where Orion's belt would have been positioned, around 2500 BCE, suggesting astronomical alignment was indeed part of the design. The shafts themselves are enigmatic, narrow passages approximately 20 centimeters square that run from the king's chamber and queen's chamber through the body of the pyramid at precise angles. German engineer Rudolf Gantenbrink, using a robot crawler equipped with cameras, explored these shafts in 1993 and discovered that they don't exit the pyramid as ventilation shafts would. Instead, they terminate at small doors with copper handles. The southern shaft from the king's chamber is angled at 45 degrees and points toward Al-Nitak, the brightest star in Orion's belt. The northern shaft points toward the circumpolar stars, including Thuban, which was the pole star when the pyramid was built. The southern shaft from the queen's chamber points toward Sirius, the brightest star in the night sky, which the Egyptians called Sopdet, and associated with the goddess Isis. These alignments, documented by astronomer Virginia Trimble in research published in the journal Mitteilungen des Instituts für Orientforschung in 1964, and confirmed by subsequent studies, suggest the builders had detailed knowledge of stellar positions and movements. They were tracking specific stars for reasons beyond simple timekeeping or navigation. In Egyptian religious texts, including the pyramid texts inscribed inside pyramids from the 5th and 6th dynasties, around 2300 BCE, there are references to the dead pharaoh ascending to the sky and joining Osiris in Orion, becoming one of the imperishable stars, the Ak-Ikem Sek. The texts describe the soul traveling through the Duat, the underworld or night sky, guided by stars. But Giza is not alone in its stellar alignments. Across the world, ancient cultures built monuments oriented to the sky with precision that suggests systematic astronomical observation over long periods. At Stonehenge in Wiltshire, England, the massive stone circle built in phases between 3000 and 2000 BCE. The main axis is aligned with the sunrise at the summer solstice on June 21st, when the sun rises above the heel stone, a large sarsen stone standing outside the main circle. Its light passes through the center of the monument, illuminating the altar stone. Archaeoastronomer Gerald Hawkins from Boston University proposed in his book Stonehenge Decoded, published in 1965, that the monument functioned as an astronomical computer, with the positions of stones marking the rising and setting points of the sun and moon at different times of the year. Allows prediction of eclipses and seasonal changes. In the Boyne Valley of Ireland stands Newgrange, a passage tomb built around 3200 BCE, older than both Stonehenge and the Egyptian pyramids. The tomb consists of a long stone corridor leading to a central chamber covered by a massive earthen mound. Above the entrance is a specially constructed opening called a roof box, and once per year, during the winter solstice on December 21st, sunlight enters through this opening and travels down the 19-meter passage. For approximately 17 minutes, the inner chamber is illuminated by a shaft of golden light, an event that still occurs 5,000 years after construction. Archaeologist Michael O'Kelly, who excavated and restored Newgrange in the 1960s, was present for the winter solstice sunrise in 1969, and described it as an extraordinarily moving experience. The precision required to achieve this effect through a 60-centimeter opening, after constructing a passage underground, suggests advanced surveying skills and multi-generational planning. Far from Europe, in the Valley of Mexico, the ancient city of Teotihuacan was laid out according to a precise grid, oriented 15.5 degrees east of true north, a peculiar alignment that puzzled archaeologists until they realized it matches the setting point of the Pleiades star cluster, as it appeared around 150 CE when the main structures were built. The Pleiades were deeply significant to Mesoamerican cultures. The Maya used their heliacal rising, the first appearance of the cluster at dawn after being invisible, to calibrate their calendar, and the Aztecs, who came to Teotihuacan centuries after it was abandoned, believed the city was where the gods created the current world. The Pyramid of the Sun, one of the largest structures in the Western Hemisphere, measuring 225 meters at its base and 65 meters tall, is oriented so that the sun sets directly in front of it on 2 days each year, April 29th and August 13th. These dates are 105 days apart and correspond to important moments in the Mesoamerican calendar. Scholars including archaeoastronomer Anthony Aveni from Colgate University, who has studied Mesoamerican astronomy for over 40 years, suggest that the entire city of Teotihuacan was designed as a cosmogram, a physical representation of the universe, with the Avenue of the Dead representing the Milky Way, and the pyramids representing sacred mountains where earth meets sky. At Chichen Itza in Yucatan, Mexico, the pyramid known as El Castillo, or the Temple of Kukulkan, demonstrates one of the most dramatic astronomical phenomena in ancient architecture. The pyramid has 4 staircases, each with 91 steps, plus the platform at the top, making 365 total, matching the solar year, on the spring and autumn equinoxes around March 21st and September 22nd. As the sun sets, shadows fall along the northern staircase in a way that creates the illusion of a serpent descending from the top of the pyramid. 7 triangles of light appear on the balustrade, each one approximately 2 meters tall, forming the body of a snake. And at the base of the staircase is a carved serpent head, so the effect is that Kukulkan, the feathered serpent god who brought civilization to the Maya, appears to slither down from heaven to earth. This phenomenon lasts for approximately 45 minutes and only occurs on the equinoxes when the sun crosses the celestial equator. The Maya built the pyramid specifically to create this effect, encoding the equinox into stone. Even farther across the Pacific, at Angkor Wat in Cambodia, the massive temple complex built in the early 12th century CE by King Suryavarman II is aligned to the spring equinox. The main entrance faces west, unusual for Hindu temples which typically face east toward the rising sun, but this orientation allows the sun to rise directly behind the central tower during the equinox, creating a dramatic silhouette. Researcher John Grigsby, in his book Orion's Door, published in 2006, noted that the temple's layout corresponds to the constellation Draco, as it appeared around 10,500 BCE, the same date that Robert Bauval calculated for the Giza-Orion correlation, suggesting that Angkor Wat might have been built on a site that had astronomical significance for much older cultures. Among the Hopi people of northeastern Arizona, researchers including Frank Waters, who lived with the Hopi and documented their traditions in his book of the Hopi, published in 1963, noted that the arrangement of Hopi villages across the landscape corresponds to the constellation Orion. The three mesas where the villages sit match the three stars of Orion's belt, and the placement of specific villages matches the positions of other stars in the constellation. The Hopi themselves speak of the ant people who sheltered them underground during previous worlds that were destroyed by fire and ice, and when they emerged, the ant people taught them how to organize their villages according to the patterns of stars. Here's what we're left with. Cultures separated by oceans, by thousands of years, by completely different languages and religions, all building monuments aligned to the same stars: Orion, the Pleiades, the solstices, and equinoxes. Why? What were they trying to preserve or communicate by encoding astronomy into their most important structures? One answer from mainstream archaeology is that these alignments served practical purposes. Tracking the sun and stars allowed agricultural societies to create accurate calendars. Knowing when to plant and harvest crops was essential for survival. And monuments that marked these times would naturally be important.
The alignments also had religious significance. In many cultures, the sky was seen as the realm of gods and ancestors. Aligning temples with celestial events connected the earthly and divine realms. But there's another possibility, suggested by researchers including Graham Hancock and Robert Bauval in their book The Message of the Sphinx, published in 1996. What if the astronomical alignments were intentional messages, time capsules designed to communicate across millennia? If you want to preserve knowledge for future generations who might speak different languages, who might have lost all written records, who might not even know your civilization existed, you encode it in the most permanent materials available, stone, and you align it with the most permanent reference frame available, the sky. Because while languages die and empires fall and libraries burn, the stars remain. Their patterns shift slowly through the 26,000-year precession cycle, but they're recognizable. Orion's belt will look essentially the same 10,000 years from now. And if you align your monument to a specific stellar configuration at a specific moment in the precession cycle, then anyone in the future who understands astronomy can calculate backward and determine exactly when the monument was aligned, giving them a date, a timestamp, a way to understand when you existed. Maybe that's what these monuments are, not just temples or tombs, but archives, libraries written in stone and star positions, preserving knowledge that their builders feared would be lost, knowledge about cycles of catastrophe, about the precession of the equinoxes which takes specialized observation over thousands of years to detect, about mathematical relationships between Earth's dimensions and the cosmos, knowledge that suggests the builders, or the cultures that influenced them, had been watching the sky and keeping records for far longer than conventional history allows.
And if that's true, then the question becomes, what else did they encode? What other messages are hidden in the geometry and alignments of ancient structures? And are we finally ready to read what they wrote in stone? Chapter 7. The Return. Will the ice come again? You're standing on the coast of Norway, near the small town of Tromsø, located 350 kilometers north of the Arctic Circle, watching the dark waters of the North Atlantic roll in. The wind is cold even in summer, carrying with it the smell of salt and something deeper, something ancient. Beneath the surface of these gray waves, invisible but powerful, flows the Gulf Stream, a massive river of warm water moving at approximately 100 million cubic meters per second, carrying heat from the tropical Atlantic northward at speeds reaching 2 meters per second. This current, measured by the rapid array of oceanographic sensors deployed across the Atlantic at 26 degrees north latitude, is the reason Europe is habitable. Without the Gulf Stream, London at 51 degrees north latitude would have the climate of Winnipeg, Canada, which sits at the same latitude but experiences winter temperatures averaging -16 degrees Celsius. Paris would be frozen half the year. Scandinavia would be uninhabitable ice fields. But something is changing. Something that makes climate scientists at institutions like the Potsdam Institute for Climate Impact Research in Germany and the Woods Hole Oceanographic Institution in Massachusetts publish papers with titles that sound like warnings. The Gulf Stream is part of a larger system called the Atlantic Meridional Overturning Circulation, often abbreviated as AMOC, which functions like a planetary conveyor belt. Warm, salty water from the tropics flows north along the surface. As it moves into colder regions, it cools and becomes denser, eventually sinking in the North Atlantic near Greenland and Iceland in a process called deep water formation. This dense water then flows south along the ocean floor back toward the equator, completing the circulation. The entire system transports approximately 1.3 petawatts of heat northward. That's 1.3 million billion watts, roughly equivalent to 100 times the entire energy consumption of human civilization. But measurements taken over the past 70 years show the circulation is weakening. A study published in the journal Nature Climate Change in February 2021 by researchers at Maynooth University in Ireland and University College London analyzed multiple data sources, including temperature records, salinity measurements, and sediment cores, and concluded that the AMOC is at its weakest point in over 1,000 years, having declined by approximately 15% since the mid-20th century. The cause of this weakening is well understood: melting ice sheets in Greenland, which has lost approximately 4.7 trillion tons of ice between 1992 and 2020, according to satellite data analyzed by NASA's Goddard Space Flight Center. This ice melt releases massive volumes of fresh water into the North Atlantic, approximately 280 billion tons per year, averaged over recent decades. Fresh water is less dense than salt water, so it floats on the surface, and when it accumulates in the regions where dense water normally sinks to drive the deep circulation, it prevents the sinking. The conveyor belt slows, less warm water flows north, and the system begins to weaken. Computer models run by climate scientists, including Professor Stefan Rahmstorf from the Potsdam Institute, suggest that if melting continues at current rates or accelerates, the AMOC could reach a tipping point, a threshold beyond which the circulation collapses rapidly within decades rather than centuries. Some models published in the Proceedings of the National Academy of Sciences in 2023 estimate this could occur as early as 2025 to 2070, though the uncertainty range is large, and other studies suggest the collapse might not happen until after 2100. What would an AMOC collapse mean? The consequences would be severe, and paradoxically, would include regional cooling in the northern hemisphere, even as global temperatures continue to rise from greenhouse gas emissions. Europe could experience temperature drops of 5 to 15 degrees Celsius within a span of 10 to 50 years, making winters brutal and summers short. Agriculture across northern Europe would fail as growing seasons shrink. Staple crops like wheat and barley that currently thrive in France and England would no longer be viable at those latitudes. Energy demands for heating would skyrocket. Ecosystems from the boreal forests of Scandinavia to the fisheries of the North Sea would collapse as species unable to adapt to rapid temperature change die off. And sea levels along the U.S. East Coast would rise faster than the global average, potentially adding an additional 50 centimeters to baseline projections. Because the weakening of the AMOC reduces the gravitational pull that currently holds water away from the North American coast. Cities like New York, Boston, and Miami, already vulnerable to storm surge and sea level rise, would face accelerated flooding. But here's what should terrify you. This has happened before. The shutdown of the AMOC, or its prehistoric equivalent, is precisely what many climate scientists believe triggered the younger Dryas cold period that we discussed in the first chapter, approximately 12,800 years ago, when the Laurentide ice sheet covering Canada was melting. Vast quantities of fresh water were held back by ice dams, forming enormous glacial lakes. The largest was Lake Agassiz, which, at its maximum extent, covered an area larger than all the modern Great Lakes combined, approximately 1.5 million square kilometers, containing more water than all current lakes on Earth, when the ice dams failed catastrophically, possibly triggered by earthquakes or the impact events proposed by the Younger Dryas impact hypothesis. This water flooded into the North Atlantic in a matter of weeks or months. Some estimates, based on geological evidence of massive flood channels, suggest discharge rates reaching 10 million cubic meters per second, 100 times the flow of the Amazon River. The influx of cold, fresh water shut down the ocean circulation. The Gulf Stream stopped carrying warmth north, and temperatures across the northern hemisphere plunged. Ice cores from Greenland, analyzed by the North Greenland Ice Core Project, show temperature drops of 10 to 15 degrees Celsius in Greenland occurring within a decade, possibly within 3 years, according to some interpretations of the data. And this cold period lasted for approximately 1,200 years before the circulation reestablished and the warming resumed. During that time, megafauna, including mammoths and giant ground sloths, went extinct. The Clovis culture in North America disappeared from the archaeological record, and human populations globally faced extreme environmental stress. If it happened once, if the system flipped that quickly 12,000 years ago, there's no reason to believe it couldn't happen again. The physics are the same. The vulnerabilities are the same. Only now, instead of scattered bands of hunter-gatherers trying to survive the climate shift, we have 8 billion people, most living in coastal cities, dependent on global supply chains, industrial agriculture, and stable climate patterns. Beyond the scientific evidence of ocean circulation collapse,
There are researchers who see patterns of cyclical catastrophe operating on even longer timescales. Randall Carlson, the geological researcher we encountered earlier, who has studied the channeled scablands and other evidence of catastrophic flooding, argues that Earth periodically passes through the Taurid meteor stream, a broad debris field left behind by a comet that fragmented approximately 20,000 to 30,000 years ago. The debris spread out along an orbital path that Earth crosses twice per year, once in late June and again in late October and early November. Most years we pass through relatively empty sections of the stream and see only minor meteor showers. But every few thousand years, according to Carlson's analysis of historical records and astronomical data, Earth encounters denser concentrations of material, increasing the probability of impacts or airbursts from fragments large enough to cause significant damage. Carlson points to the Tunguska event of June 30, 1908, when something exploded in the atmosphere above Siberia, with force estimated at 10 to 15 megatons of TNT, equivalent to 1,000 Hiroshima bombs, flattening 2,000 square kilometers of forest. The object was likely a fragment of comet or asteroid, approximately 60 to 100 meters in diameter, that exploded at an altitude of 5 to 10 kilometers. If a similar object exploded over a populated area today, it would kill millions. And Tunguska occurred during Earth's passage through the daytime branch of the Taurid stream, suggesting the connection Carlson proposes is plausible. He estimates, based on orbital mechanics and the density of debris, that major encounter events with multiple large fragments could occur on cycles of approximately 3,000 to 5,000 years.
and the last major event may have been the younger Dryas impacts around 12,800 years ago, meaning we could be approaching another encounter window. This idea of cyclical catastrophe also appears in ancient calendars and mythologies. The Maya long count calendar, which measures time in units called baktuns, each lasting approximately 400 years, completed a major cycle of 13 baktuns on December 21, 2012, a date that generated worldwide apocalyptic fears based on misinterpretations of Maya cosmology. The Maya did not predict the world would end in 2012, but they did believe in cycles of creation and destruction. Their mythology, recorded in texts like the Popol Vuh, describes multiple worlds that were created, flourished, and were destroyed before the current world. Each destruction was different. One world ended in flood, another in fire, another when the sky fell and darkness covered the earth. These weren't seen as random events, but as natural cycles, the universe breathing in and out, death and rebirth on cosmic timescales. The concept of cyclical time appears across cultures. In Hindu cosmology, time moves in vast cycles called yugas. The current age is the Kali Yuga, the age of darkness and decline, which began approximately 5,000 years ago and will last for 432,000 years before the cycle resets and a new golden age begins. These numbers are symbolic rather than literal, but they reflect a worldview where destruction and renewal are inevitable parts of existence, not aberrations, but patterns. In Norse mythology, Ragnarok describes the end of the world in fire and flood, but after the destruction, the earth rises from the sea renewed, and a new generation of gods and humans begins again. Even in modern Western thought, which tends toward linear conceptions of progress and history, there are echoes of cyclical catastrophe in the work of catastrophists like Immanuel Velikovsky, whose controversial books Worlds in Collision, published in 1950, and Earth in Upheaval, from 1955, proposed that planetary near collisions and cosmic catastrophes shaped human history within recorded time, though his specific claims have been thoroughly debunked by astronomers and geologists. The underlying intuition that catastrophe is cyclical rather than random continues to find support in disciplines from impact geology to climate science. So here we stand, at a moment in history where multiple lines of evidence, scientific measurements of ocean circulation, geological studies of past climate shifts, astronomical analysis of meteor streams, and ancient mythologies of cyclical destruction, all point toward the same uncomfortable conclusion. The stability we've experienced for the past 11,700 years since the Younger Dryas ended and the Holocene epoch began is not normal. It's an anomaly. A brief calm window in a planetary system that operates on cycles of ice and warmth, advance and retreat, catastrophe and recovery. Based on natural orbital mechanics alone, Earth should remain in the current interglacial period for several thousand more years before the next glacial cycle begins. But human activity has disrupted the system in ways that make predictions uncertain. Greenhouse gas concentrations are higher than they've been in over 3 million years. Arctic sea ice is disappearing at rates that exceeded even the most pessimistic models from 20 years ago. Ice sheets in Greenland and West Antarctica are losing mass faster than they're gaining it through snowfall. And the ocean circulation that keeps Europe habitable is weakening. We're conducting an uncontrolled experiment on the only planet we have, pumping carbon dioxide into the atmosphere at a rate of approximately 40 billion tons per year, warming the Arctic twice as fast as the global average in a phenomenon called Arctic amplification, melting permafrost that releases methane, a greenhouse gas 28 times more potent than carbon dioxide over a century, and destabilizing ice sheets that, if they collapsed completely, would raise sea levels by over 60 meters, enough to drown every coastal city on Earth. But here's the paradox that keeps climate scientists awake at night. The same warming that could eventually lead to catastrophic sea level rise could also trigger a shutdown of the AMOC, which would cause rapid regional cooling in Europe and North America. So we could face a scenario where some parts of the world experience unprecedented heat, while others plunge into cold, where global warming and regional ice ages happen simultaneously. And historical precedents from the younger Dryas suggest the transition between states can happen within a single human lifetime, possibly within a decade. Maybe the real lesson of the Ice Age isn't that it destroyed a civilization. Maybe it's that civilizations always think they're the exception. They always believe they've mastered nature, that they've built something permanent that will last forever. The mammoths grazed peacefully for millions of years and thought the grasslands were eternal. The people of Doggerland lived on coastal plains for thousands of years, never imagining the sea would rise 100 meters. The Atlanteans, if they existed, built their ringed city and believed their walls would hold back the ocean. And we build skyscrapers on coastlines, plant crops in regions that will become deserts, pump water from aquifers that won't refill, and tell ourselves that technology will save us, that we're different from every civilization that came before, that the ice won't return, that the seas won't rise, that catastrophe happens to other people in other times, never to us. But the Earth doesn't care about our assumptions. The Earth runs on cycles driven by orbital mechanics that operate over tens of thousands of years, by ocean dynamics that can flip between stable states in decades, by impact probabilities that guarantee eventually something large will hit. These aren't moral judgments or divine punishments. They're physics. And physics doesn't negotiate. The question isn't whether the cycle will turn again. The question is when, and whether we'll be ready. Whether we'll have encoded our knowledge in forms that survive the next catastrophe. Whether we'll be the survivors who become the teachers, the ones who preserve memory and pass it forward. Or whether we'll be the ones who are forgotten, buried under ice, or drowned beneath rising seas, remembered only in myths that future civilizations dismiss as fantasy. And maybe that's the real message hidden in all those ancient monuments aligned to the stars, in the temples deliberately buried like Göbekli Tepe, in the myths of gods who appeared after the flood bringing knowledge to scattered survivors. Maybe they weren't trying to tell us what happened in the past. Maybe they were trying to warn us about what's coming in the future. Because they knew something we've forgotten, that the wheel always turns, that catastrophe always returns, and that the only way to survive is to remember, to prepare, to encode our most important knowledge in forms that outlast words and languages and digital systems, to build in ways that endure beyond empires and ice ages, and to hope that when the sky burns and the waters rise, someone will be left to read what we wrote in stone. So here we are, at the end of this journey through ice and flood and forgotten time. And what have we found? We found that the Ice Age was not just a slow planetary cooling that ended gently. It was a reset button pressed 12,800 years ago when something fell from the sky, or the ocean currents collapsed, or both happened simultaneously. And within decades, possibly within years, the world changed so drastically that entire species vanished, coastlines drowned, and whatever civilizations existed before that moment were erased so completely that we're left arguing over fragments. We found evidence scattered across the seafloor and buried under soil, nanodiamonds in the sediment measuring just nanometers wide, frozen mammoths with unswallowed grass in their mouths, temples like Göbekli Tepe carved with astronomical precision by people who weren't supposed to know how to build, cities like Dwarka submerged under 40 meters of water, and monuments from Giza to Stonehenge to Teotihuacan aligned to stars with accuracy that suggests someone was watching the sky for thousands of years and encoding what they learned into stone. We found myths that refuse to go away, flood stories told by cultures separated by oceans and millennia, from the Sumerian Ziusudra to the biblical Noah to the Maya Popol Vuh to the Inca Viracocha, all describing the same pattern: a world destroyed by water, a handful of survivors, and teachers who appeared afterward bringing knowledge of agriculture and astronomy and architecture. Gifts that seemed divine to people who had lost everything, teaching them how to grow crops, how to track Venus through its 584-day cycle, how to understand the 26,000-year precession of the equinoxes, how to build temples that would survive the next catastrophe. And we found that the forces which shaped those catastrophes, the orbital mechanics that govern ice ages measured in 100,000-year cycles, the ocean currents that transport 1.3 petawatts of heat and can flip between stable states in decades, the meteor streams like the torrids that Earth passes through twice per year, the melting ice sheets releasing 280 billion tons of fresh water annually into fragile circulation systems. None of these forces have stopped. They're still operating, still cycling, still turning the wheel that has crushed civilizations before. The lesson isn't that we're doomed. The lesson is that we're part of something much larger than ourselves, a planetary system that breathes in cycles of ice and warmth. And those cycles don't care about our technologies or our beliefs. The lesson is that knowledge is fragile, that it can vanish in a single generation when the people who carry it die without passing it on. That writing was invented not just for record-keeping, but as insurance against forgetting. That the survivors of the younger Dryas, whoever they were, understood this better than we do, because they'd watched their world burn and drown. And when they emerged from the catastrophe, they didn't just rebuild, they encoded. They carved their warnings into 15-ton stones at Göbekli Tepe and 2.5-ton blocks at Giza. They aligned monuments to true north within 3 arc minutes of accuracy. They buried time capsules 300,000 cubic meters deep. They left messages that would survive floods and fires and the collapse of languages, because they knew that catastrophe would come again. The lesson is that the Earth doesn't owe us stability. It doesn't owe us the 11,700 years of unusually calm climate that we've enjoyed since the Holocene began. We're living on borrowed time, in a warm window between ice ages, and the window is closing. The Gulf Stream has weakened by 15% since the mid-20th century. Ice sheets have lost 4.7 trillion tons of mass in less than 30 years. We're pumping 40 billion tons of carbon dioxide into an atmosphere that hasn't seen these concentrations in 3 million years. And we're standing at the edge of the same precipice that the Ice Age survivors stood at. The moment when the world changes, and we have to choose. If this journey has shifted something inside you, if you feel a little more humility before the vastness of time, a little more urgency about what we're doing to this planet, a little more wonder at the resilience of those who came before and left us these messages carved in stone and aligned with stars, then I want to ask you to do something. Hit the like button right now. Let's see how many of us are awake, how many of us understand that these questions matter, that the wheel is still turning, that the ice is patient, and the ice always returns. And leave a comment. Tell me what surprised you most, what question still haunts you, what you think we should be doing differently. Because this conversation needs to continue, this remembering needs to spread, and your voice matters in that conversation. And if you want to continue exploring these mysteries with me, if you want to walk through the next chapters of the hidden timeline, then subscribe to this channel, because this is just the beginning. There are 49 more journeys waiting, each one revealing another layer of evidence, another connection between ancient wisdom and modern discovery, another piece of the puzzle that mainstream archaeology has ignored because it doesn't fit the accepted narrative. We'll explore the mathematical codes hidden in the Great Pyramid, the astronomical knowledge embedded in Angkor Wat, the acoustic properties of megalithic chambers, the geometric relationships between sites separated by thousands of kilometers, and we'll keep asking the questions that need to be asked, not because we have all the answers, but because someone needs to remember to ask. Save this video to your playlist, share it with someone who needs to hear it, because this isn't just information, this is a warning and a promise. A warning that the stability we take for granted is temporary, that the ground beneath our feet is not as solid as we think, that the climate we depend on can flip in a decade, and a promise that if we're brave enough to remember, wise enough to encode, humble enough to learn from those who survived before us, then maybe, just maybe, we'll be ready when the cycle turns. Maybe we'll be the ones who leave the warnings for the next world, carved in stone, aligned with stars, waiting in the silence for someone brave enough to listen. Now rest. Close your eyes if you need to. Let the silence settle, because the silence remembers what we've forgotten. And in that silence, if you listen carefully, you can hear them. The survivors, the teachers, the builders, the ones who watched their world end and chose to encode rather than despair. And they're telling us what they learned, that catastrophe is not the end, that knowledge survives if we're brave enough to preserve it, that the stars will guide us if we remember how to read them, and that somewhere beyond the ice and the flood and the forgetting, there's always another beginning, another chance, another sunrise over ruins that will become foundations. And all we have to do is remember, and build, and hope, and teach the next generation to do the same, because the wheel always turns, the cycle always returns, and the only way to survive the end of the world is to make sure that someone remembers how the world began. So breathe, settle in, and know that you're part of this now, part of the remembering, part of the encoding, part of the long chain of knowledge that stretches back to the Ice Age and forward to whatever comes next. And that's enough. For now, the ice waits, the stars turn, and the path continues, always.